Yes.
in A level?
Well, no, I don't.
No? In GCSE?
Yes.
Right. How's it going?
It stopped me from learning more.
Hmm. Well, hopefully you can learn some things today. I
Oh, yeah,
probably won't be
Thomas.
talking about specific maths though, but
Yeah, Thomas has a bunch of people breaking their heads open over this self-referential calculus problem. Did
oh
you
yeah, I
pick
saw
that one because it was real tricky, or
that.
It was
yeah?
just kind of weird, so
Hmm.
I
Yes.
thought, why not do it?
Right. Yeah. How's it going?
It stopped me from learning more.
I didn't see what you guys did, but I think you can take logs of both sides and then use implicit differentiation.
Yes, I'm pretty sure I
So-
did that.
Cool. How come you know calculus when you're in GCSE?
What do you mean, how do I know?
Yeah, how
I
did
just
that come
know it.
about? Through divine inspiration, or
Just got interested
like
and
through
learnt it.
YouTube?
Yes,
Cool.
precisely.
What about maths is attractive to you?
It's just, well, I mean, it's quite fun.
Yeah, that
And
moment of
also,
solving the problem where you just like didn't have it and then you just get it.
yeah, that one's pretty good.
Yeah. I also learnt mathematics early as well. And for me, like my driving force was actually competition, which I've grown up a little bit, and that's not my driving force anymore. And I'm kind of glad that like I shifted gears from being motivated by knowing more than other people or beating my classmates, and now I just do it for myself. But it's good that you're already like doing it for yourself. That's impressive.
I already have a shit talker. It's Wonder Crab. He's calling us bean counters.
Bean counters. Okay, that's
All right, let's
interesting.
go
Like,
home. Forget it. Call us a bean counter.
but so in terms of like what mathematics is, if you ask any like grandparents, like or anybody who's not done maths for a while, they will think of it as like, oh, are you doing your 15 times tables, or are you, calculating the length of the hypotenuse, right? They'll see it as like a very much a calculation based thing, and that's how I saw it for a while as well. I've shifted from that perspective of what mathematics is to something more. For me, mathematics is about storytelling. What I mean by that is you can take a mundane fact or a mundane calculation, such as -1 times -1 is 1.
Yeah.
And there's many ways you can justify it. You could justify it algebraically. You could justify it just by being dogmatic, saying that's the way it is. Or you could tell yourself a story, like a fun story, as to why it's true. And okay, I've got a lot of like emotion behind this, and I'm not sure how much is going to come out, but I'll try my best. So there are certain stories that you can tell about things which feel as if they have content. For example, the story that I told myself when I was younger about why -1 times -1 is 1 is it's to do with rotation. Like -1 is kind of like a rotation by 180 degrees, and 2 rotations brings you back to where you start. Now, I got lucky because I didn't know about complex numbers, in which multiplying a complex number is rotation. I'm not sure if you've seen that yet. But
Yeah, e to the I theta equals the cosine of theta plus I sine of theta. Correct?
that's it. Exactly. So if you're multiplying by -1, that is a 180-degree rotation. So, but what's kind of funny about that is I didn't know anything about that, and yet I told myself that story when I was a kid, and it later turned out to be a useful story, which kept on giving, and it keeps on giving. It gives beyond the complex numbers as well. So there are certain narratives that have content, and there are other narratives that don't have as much content. And the thing that I'm sort of puzzling over is any of it real? Is it all just like illusory content And is the only thing that really matters is the calculation? I know, like, telling yourself a narrative and a story can help you think of new ideas and help you solve problems. But is it like a trick? Or is there like actual content beyond the calculations? Hopefully that point was clear. What do you think? And I can give some other examples. So
For me, basically, what I think is, I think that, well, the universe can be expressed as mathematics in that physics is a way of describing how the universe works, and maths is the language that it's best expressed in. That's how I think of it. Not sure
that's
about
interesting.
I had a 3-hour argument on my show yesterday about this exact subject, so I'm really fascinated that it's come up again so quick. I think maybe somebody already knows I'm going to say we have to define a language. Dun, dun, dun.
Well, I would like you to talk about that, Jen, because I have my own opinions, but I'd prefer to hear someone else's before my own.
I don't even want to have opinions on that.
Okay.
If you were me,
Okay.
would you want to have an opinion on what a language was after all the controversy? All the bullshit.
Well, I haven't been keeping up with the drama. But
all I'm saying is it's okay. There are multiple definitions that could work. And when we say language, we have a colloquial understanding. Do you know what that word is?
Yep.
So does that mean that when someone technically refers to it, that it is it the same definition? Probably not. So it all depends on whether, and to me at this point, what seems to be is, I don't want to say it all depends, but it seems to depend largely on whether there's a symbolic representation necessarily.
Mm-hmm.
Spoken language doesn't necessarily have a symbolic representation, but mathematics does. And I got in a pretty much 3-hour argument about that yesterday. It seemed to be self-evident, so there was obviously some language problem, definitional understanding, and how we define a language.
I have a lot to say about that then, because let me try and organize my points. So, to the point of like, can reality be described by physics? Well, yeah, of course, it can be modeled by it. It can be approximated by it. Can it actually truly be captured by mathematics? I'm a complete skeptic on that. And I didn't used to be a skeptic. In fact, when I was in GCSE and A-level, I would believe my physics teachers when they would tell me, this is how reality works by Newton's equations. And then when you later find out that they don't quite work, I would then believe the next one, right? And then when I was given a childish model of how the electron worked, of like little planets orbiting around things, I'd believe that. And then, the next chemistry teacher, one level up, would say, oh, that previous model that we were talking about, it was just kind of a cartoon. This is the real one. And then when you keep going, there's like, and now we have equations. This is the real one. But then there's always the next person to stomp on the previous idea. And after a while, you start to be a bit skeptical, like, okay, can it ever truly be like finalized? Can you reach the ultimate where you've
Can I just jump in with something real quick? This reminds me of the time I found out that like the Tooth Fairy wasn't real and the Easter Bunny wasn't real, and then finally Santa wasn't real, and then I'm sitting in church one day, is like, wait a minute, are they just going to tell us one day that God's not real? The story totally reminded me of that. I'm sorry it's non sequitur. I just had to jump in with it. Please continue, unless you wanted me to say something about the content of your mathematical observation.
No, I mean, that is relevant. For me, it's the same thing. I mean, you learn some stories, and each time they sort of get squashed. You start to be skeptical of stories in general. I mean, it's no different than doubting God because of all these other fairy tales which seem similar in content that got stomped out. But going back to like what you said, Jan, like, physicists and mathematicians, they have language to describe things.
I don't consider math a language. I should probably stop you here. I don't think it's accurate to refer to math as a language.
That's interesting. Why?
Because it doesn't exist without symbolic representation. The language we're speaking right now, we could burn every dictionary that exists. We'd still speak English. Math arose in the context of a language. It's not about whether you could. It's about what came first. Math never came about without a language that existed prior.
I
You have a
disagree.
language without math. Okay. What you're calling math isn't math then. You're saying the symbolic representation. Okay. You're saying the order of nature is equal to the symbolic representation of mathematics if you don't make that distinction. It's like, what orders nature? We don't have access to that in terms of a symbolic representation.
I agree with you on that point. So let me be clear what like I'm going to call math. Okay? Because for me, mathematics for me is not the language. Let me be clear that I agree with you on this, but maybe I have different opinions. So what I'm calling mathematics is something really specific that I haven't quite grasped fully. So if I write down some equations on a piece of paper, I will colloquially, as you probably would as well, call that mathematics, right? And you know, I probably wouldn't point out to things in the universe like the orbits of the planets and call them mathematics. I'd call that physics. So I'm really specific when I'm pointing to things and calling it mathematics. And it's something which transcends language. Okay, let me try and give you an example. So you know, like a mathematician might want to describe containment, like this thing is contained in this thing. And then they develop this language called set theory. And I would call set theory a language, or I would call it a formalization, right? Let's not get bogged down on the words. But my point is, I'm trying to make a distinction between the formalization and the thing that we're trying to formalize. And I choose to call the thing that we're trying to formalize, I call that mathematics. And the formalization, I'll colloquially refer to it as mathematics, but I won't treat it as real mathematics. I'll treat it as like the map of the place. Okay.
So mathematics is the territory, and other thing that we're also calling math that we shouldn't is the map.
Yeah, and I
can we
would
agree we need to refer to them as separate words, or at least make a distinction? I don't actually care what the words end up being, but if we don't make that distinction, we're going to be conflating map and territory.
yeah, maybe. I don't know if we do need words. I don't know how useful that would be. And what's kind of interesting though is I'm skeptical that the thing I'm trying to like, I'm skeptical that the territory exists in the first place. So, you know, like I call myself a mathematician, I do maths, and I spend my time thinking about these abstract objects. Okay. And I would refer to those things that I'm thinking about as the territory. And if I was to write it down on a piece of paper, I'd call it colloquially mathematics. But I know the thing I really truly care about is the abstract object that I'm thinking about, not the way I've formalized it on a piece of paper. Because I can take any object and I can formalize it in a myriad of different ways. It's kind of like you go bird watching, right? And there's this pond and there's birds flying around. And I don't know if you've gone bird watching, but there's like sometimes these little bunkers that you can sit in and they're dotted around the pond, right? So I could go in like bunker number 1 and look at the birds from a certain angle, you know, and learn something about them. And I can go in bunker number 2 and look at the birds and learn something different maybe because I'm seeing them from a different angle. My point is that there are all these bunkers, all these formalizations of things that people care about, containment, right? Set theory is one way to describe containment. You know, and there's geometry, there's shapes, and there's all sorts of ways to formalize that. You talk about, you know, Cartesian coordinate systems. That's one way to formalize geometry. And there are other ways to formalize geometry without this system. The issue is, do the things that we're trying to formalize even exist? And this
Amazing,
kind of relates to
beautiful
Platonism.
question. I love that
Are
question.
you a Platonist, Jen?
Oh, that's a great question. But honestly, Thomas said he could only be with us for 30 minutes. And I know he said he had to go to bed. So I would actually, if you don't mind, because that's a super involved question that I want to give it the time it needs. But maybe we could just take a little bit of time to talk to Thomas before he's got to go.
Yeah, of course. Okay,
Did
Thomas.
you want to shoot us some questions or whatever? Like, he basically agreed to come when I wasn't sure if you were going to come. I just want to make sure I had a backup, but very much appreciate that. But do you want to either ask a question or contribute something with regards to how you feel about math? All commentary is welcome. We can't hear you, Tana. Sometimes the audio stops working, so you have to like rejoin.
Yeah. If you want to close out and come back in, it might work.
Anyway. But yeah, that's amazing. So I just want to clarify my understanding of what you said before I launch into a big thing, but are you saying that all manners of formalization are somehow equivalent?
Equivalent. No, I'm not saying that. I'm saying because there are different types of ways to formalize things, and some have different virtues. But what they all have in common is that not capturing the full essence of the thing that I want to think about. I don't want to make conflations between the thing that I care about and the formalization of the thing that I care about.
Gotcha.
Just a quick rant before Thomas jumps in here. To finish this point very quickly, I'm tired of thinking about things that I care about and other people trying to pigeonhole me into a formalization that I'm not buying into. So I might think about containment and they'll say, oh, let's think about it in terms of set theory. Well, no. I didn't buy into the model of set theory. I'm trying to think about containment in a more abstract way. And I'm leaving myself open to formalizing myself in different ways. But they've just got this one dogmatic formalization that they are trying to pigeonhole me into. Anyway, Thomas, do you have a remark on any of this?
I'm really sorry,
Yeah.
lads.
No, it's the nature of the topic, right? How about we get a more down to earth back and forth then? So, do you have a definition of what mathematics is, Thomas?
A definition for it. Well, I feel like it's so broad that it's quite hard to have one definition for it. So not really.
Okay, how would you explain it to a Martian?
To a Martian, I'd probably explain it as, well, I mean, assuming the Martian doesn't know anything about it, I would probably start with saying, well, I mean, it's a type of like logic. Maths is a type of logic.
I'm surprised that word hasn't come up yet. That was one of the questions I was going to ask. Like, if we got super deep into this, what's the actual difference between logic and math? Turns out not to be so easy to answer, but I like where it's going. Math is a type of logic, or math requires logic? What do you think?
Well, it definitely does require logic, but I mean, sometimes, you get things that are not very logical in maths, right? Say, what is something that's not very logical in maths? Right.
Particles are not rational. Let's not talk about logic yet. Let's just say like the particles aren't rational because there's no sound evidence in support of particles. So to model things as though they were particles, that's not, quote, logical in some definition of the term, right? Colloquial definition?
What did you have in mind, Thomas?
Actually giving me all the hard questions.
Oh, yes. I mean, it's going to be hard questions all night, I hope. But when you say like something isn't logical, are you like trying to express that there's certain types of mathematics, although it makes sense? I presume it makes sense because mathematics is meant to be this consistent thing.
Yeah.
It's just hard to wrap your head around it.
Yeah, so like the question I asked not too long ago was the 1 to the power of x equals -1, find all solutions of x. Logically, that doesn't make any sense. You can't multiply 1 by itself, however many times, and get -1.
Yeah.
But in the algebra, it makes sense. That,
Are you familiar with the Banach Tarsky paradox?
The one with the sphere, right? Or the circle?
Yeah.
You find that's a source of a similar, is that a source of similar frustration?
Well, I mean, it's a paradox. I mean, it's meant to be, something that's hard to wrap your head around and something illogical.
Well, that's interesting because if you learn it at like a university course, they might not even refer to it as a paradox. They would call it the Banach-Tarsky theorem because it's something that you can actually prove within the system. So there's actually the only paradoxical thing about it is the human thing about, now that doesn't quite make sense. Mathematically though, it makes perfect sense. So
Yeah,
there's a disconnect between our human intuitions and how we've sort of formalized the system.
the maths is perfect. The flaws is with, the humans and their understanding of maths. So that
So just
raising something to the power of a complex number intuitively, that doesn't exactly make sense. Mathematically, it's totally possible.
I know exactly what you're saying. So in terms of like the Banach-Tarsky paradox, what's
Yep.
kind of interesting, like how that came about, is it came from mathematicians trying to formalize a really intuitive idea, which is how do we measure the size of certain geometric things? How do we measure length? How do we measure area? How do we measure volume? And they came up with a subject called measure theory, which exactly is the way that they're going to formalize how to measure things. And it turned out it was extraordinarily hard to formalize it. So they had to sort of correct it and correct it and correct it until they found the right way to phrase it. And they settled on it. This is the right way to phrase it. A lot of people disagree though, because their right way of phrasing it has these weird counterintuitive results. Surely if there was like a nicer way to formalize it, it would completely 100% match our human intuition. But there's a nuance here, because is it even possible to like formally formalize our human intuition in such a way that we're going to be completely happy with it and there's going to be no counterintuitive results? I don't think so. I think there's always going to be counterintuitive results. And likewise, back to the physics thing, I don't think we can formalize reality in such a way where it's perfectly exact as well, just like we can't formalize our human intuition. So there's always going to be some like dodgy stuff in mathematics, and you're either going to have to accept it or come up with a new model yourself, because people are quite dogmatic about the current models that are out there.
Or we could prove why math must necessarily be incomplete. Actually be right about it, unlike certain people. Good doubt.
That's the whole kind
That's
of
quite
worms.
obvious that, maths is incomplete. There's a lot of questions that you cannot answer in maths,
lot of people
despite
feel
them
that-
looking really.
Did you not just earlier say, and I'm not trying to put you on the spot, but I thought you said the math was perfect and we're the ones with the shortcomings. I don't know how you could
Yes.
conclude that
I mean,
based
our
on...
understanding of maths is incomplete.
That's a faith
So when-
Because
statement.
if I ask a question as easy as, I don't know, find the integral of x to the power of x, that's considered impossible. But I mean, mathematically, there is an answer to it. We just can't work it out. Because our understanding of maths
It's
is incomplete.
self-referential, right? Like the derivative's only defined. You got to go to the definition. What is a derivative? It's a slope of a tangent. The tangent's not defined.
Yes.
It's not a function. Tangent's only defined for certain classes of relations, right?
Yeah.
Okay, let me just connect the bridge, because I think there's a disconnect here. So when Jen was talking about incompleteness, she wasn't talking about like incomplete knowledge. She was talking about mathematics itself being incomplete, in the sense that there are going to be true results out there that we can't prove. Right? So there are things which are true, which we can't prove. And that kind of relates to the thing that you were saying. Like, there are going to be integrals which exist, but we can't express them. It's a slightly different thing. It's actually not related to incompleteness, but it has the same sort of flavor. There are integrals which have a definite value, which exist, because it's a continuous function, we can integrate it, but we have no way of expressing it in terms of elementary functions. The way mathematicians get around that issue is they just expand their arsenal of what they're willing to call an elementary function. So you can actually write down integrals of that type. You just can't express it in terms of like the standard results, like exponentials, logarithms, sine, cosine, and stuff like that. But okay, so I want to bring this back for a second, and also Thomas, if you ever want to drop out, just let me know. I don't want to keep you up because it's bedtime, right? But
yeah, did you want us to wrap up? Because Thomas, I know you're in high school. Like, last thing I want to do is be a bad influence on someone, much less someone in high school. So, did you want to say bye, or what do you think, Thomas?
No, I think I'll stick around for a few more minutes.
Are you on your Christmas holiday?
Yep.
That's good.
I'm in my
Okay.
Christmas holiday.
Go ahead, Euler, and then I can get to all my answers that I have ready for your comments so far.
Prepared. Okay. So what mathematics is for me, again, just to bring back my point, is it's completely about storytelling. And that's a really open definition of what mathematics is. And the reason why I'm willing to call it storytelling, and why I'm willing to like associate that as the real mathematics, is because that's what excites me. That's the part of mathematics that makes me enjoy myself. I didn't always used to think this way. I used to think that mathematics was like there's one right answer and there's usually like one or two ways to sort of get to the answer. But no, it's like really rich. You can actually create objects. You can there's this idea that's been floating around my head this past year, and it's the idea that you can make any concept work in some sense. That even the ramblings of a madman can in some sense be made coherent and has structure. So if you saw a crazy person just talking to themselves on the street and they were saying all sorts of like schizophrenic ramblings, somewhere in that mess there is like structure. Now the structure isn't formalized, it's just like ramblings of a madman, but it's hard for me to believe that there isn't some content, because wherever I look I can at least attempt to make a formalization of what anybody is saying. And this is what mathematicians do all the time. They take an intuitive concept like measurement, as we talked about before, and they formalize it. They make it a thing, or they have an intuitive notion of containment and they make set theory. So it's not like velocity as well, and calculus comes about from that. So you can formalize pretty much anything. And this is why I'm bringing up Platonism, because it seems to me if the ramblings of a madman could have some structure and content, and it doesn't exist physically, I would like to say it exists in some sense. And so there's a bunch of terms that we have here. I'm going to lay them out on the table. We have number 1, existence. What does that mean? Number 2, truth. What does that mean? 3, content. What is content? Is content different to truth? I think yes. I think content is different to truth. Let me give you an example. I think that Harry Potter, the story of Harry Potter, has content. I don't think any of it is true, but it has content. What I mean by content is it has structure. It makes sense. It gives me imagery. There's some sort of internal workings and logic in it, which I can put myself in that world and reason as if I'm inside that world. The world has content, but it's not true. I can do the same with all sorts of things as well. I can put myself in a mathematical mindset where I'm thinking about measurement as if measurement is a valid concept. It feels valid, like to a carpenter who's like measuring their table and they're saying, well, yep, this is 1 meter long. But like that presupposes all sorts of baggage about the nature of space, right? Or like it, but they
Thank
don't.
God you can see it now. Thank God. Like I feel like my work is actually paying off that you came to that. And you,
Well, I've had this for a
I
while.
don't want to say you agree
Don't
with
think you
me, but you
brainwashed me.
concur with the notion that if you can't define the distance metric accurately, basically every single time you effectuate anything equivalent to that, you're recurring the error. The error is additive.
What's
If it's on
your
that level.
What's your point? What's your feeling about this?
My feeling is I'm glad that you're looking at it on this level, because that's the level you need to look at it on, because you need to be able to reason whether things have this apparent essence or not. You were asking before, like, does anything have an essence? What does it mean for there to be a real essence to something?
Exactly. So it could be the case that like the concept of space is just like not coherent in the slightest. And yeah, I would say there is content to the carpenter saying the table is 1 meter long.
It cannot be true, because we have a concept of it. So at the very least, it means something to us. Now, it may not mean anything in the context of a unified field model. That's our arrogance to think that what we think matters to the unified field model, right? That's where we have to correct our incorrect intuitions. They don't necessarily go in the direction that would allow us to negate them, which is what needs to happen for us to be masters of physics. Which is, I think, what we're getting at, right?
Yeah. So if we're willing to entertain the fact that a fiction can have content, in some sense, a fiction has like a flavor of truth to it, then is that fiction a reality? And is it any different to anything else that I come up with? For example, I'm calling this person my mother, right? Or I'm calling this person my friend. That's probably a better example because it feels like the concept of a mother is much more like well defined in terms of biology. I would argue that it maybe is also a fiction, but like a friend, that's definitely a fiction. I mean, we just like slap a label on another person, and there's no sort of trans-dimensional entity dictating, yes, you really are friends. This is really a true state of affairs in the universe. But we're willing to all dance around on Earth, acting as if other people are our friends and other people are our enemies. And I feel
That's
like
our own
those,
hope. Sorry.
but it has
Hope, man.
content. It has content though. It's like saying
It
something.
appears
We
to
know
have
what it means.
it appears to have content. It can't be absolutely nothing because there's obviously some animating potential, but what content it truly has and what it appears to have. I mean, that's the problem. We can't get past our own subjectivity, right?
Okay, is there anything that you would point to that has real content rather than this fictional content?
We always have to come back to what does it mean for something to be real? There are two definitions of real that would be like intuitive. One would be immanent and one would be permanent. So immanent would be what's real right now. What can we materially establish has realness? Like, what are the borders of countries? It's not
Okay.
eternally real, is it? Right? Like even the shapes of the continents themselves, that's not eternally real. So if we're going to define what's real as what's immanent, it's just what's currently in the material world. That's a bad definition because the material world's always changing. What you want is permanence. What is permanent? So what never ever changes, and that's in some sense the laws of physics. And the question is, how do we access the laws of physics? And I asked about Platonism before. Now, I've taken the position of Platonism because it gets a bad rap, and I'm trying to basically
make it cool
balance
again.
things out. I don't want people to become Platonists. I want people to understand what the arguments are and to see that it's unfalsifiable in the sense that it's a model. You may not like the model, you don't understand the model, but if a model is what you call information positive, you're not really going to get rid of it because it has some utility. Stuff with utility is salient. Is that fair enough?
Wow. Okay. Yeah, that resonates with me because this is exactly what I was thinking about. Hopefully, we're on the same page here. So, there are certain things out there which have content. You used the word information there. I'm happy to use that word as well. Are we saying that content and information are synonyms?
Well, that's exactly, I mean, a matter of metaphysical primacy. We have to go back to first principles and say, we're going to agree that consciousness is this and this and this is that, and then all the other things will be a consequence of those definitions. Or we can just agree to a definition without looking at the metaphysical primitives, but then we're always going to be limited to someone else's interpretation if we do that.
Yeah. Okay. I do want to.
When you're talking about content,
go back
this
to
is how I
metaphysics.
understand. This is how I understand content. It's essentially a meaningless term because you're talking about something inside a container, and not all containers are equal. And a container does not serve as an accurate analogy for the universe, and so it's essentially a useless metaphor because the universe doesn't have a boundary. And the primary attribute of a container, containment, is a boundary, right? So your intuition there is dead on. You didn't like set theory. Why? Well, because the universe is infinite, bitch. So now you have an actual answer. As regards to content, I would say, sure, well, you can define a set. The content is the things inside the set. The data versus the set would be metadata. Okay. Fair enough? Or I haven't lost you yet, have I?
You're losing me a little bit. I'm not completely off like the boat, but
I am not defining the term content in an absolute sense. What I am defining in an absolute sense is information and data. Information's at one end of a spectrum, data's at the other. Information is literal form attributes in the Platonic sense. Now, I'm not saying the Platonists had it right, but if Platonists were right, what it would look like. So, are you familiar with any of these religious notions about the one or the absolute or anything like that?
I've heard them being thrown around, but I haven't thought about it too much. How does it relate to this?
Well, it relates to the concept of the monad. The monad
Hmm.
is, I don't want to say exactly identical, but there are things said about these grand unifying concepts between religions that are very similar, i.e., there are no words to describe the actual fundamental attributes of this thing. So there's words that allude to it, but it's included in the definition of the actual word that it is an illusion. Not an
Well,
illusion,
okay.
an allusion with an A. You know the difference in the term, right? Like
So I'm
you're
familiar
alluding
with
to
this.
something.
I've come across this a lot. You'll get a lot of religious people saying, God is this, but not all of this, because his true nature can't be grasped. They're throwing out there a concept that we can sort of, see a little bit of it, peek at a little corner of it, but we can't ever see all of it because it's just too big. And I've had this a lot where I've been in a discussion and somebody will bring up the example of, can you conceptualize infinity? And they're just wanting the quick response back. They're expecting the answer to be no, of course not. Infinity is so big it can't be conceptualized. You can't contain all of infinity in your mind. And my answer is, yeah, of course I can conceptualize infinity. I do it all the time. And they will say, well, you're not. I mean, you're just wrong. You can't do it. It's not possible. But in my mind, I've completely conceptualized it in many different ways. I have a visual understanding of it. I have a formal understanding of it. I can understand it in lots of different ways. There are concepts which people claim are inconceivable, and yet in some sense I feel as if I've grasped the concept. Now this is interesting because there is this notion of grasping a concept, and I feel as if I've grasped the concept of infinity. Not all types of infinity, I'm just talking about like simple versions of infinity. But I feel as if I have, and they're claiming, no, you're just wrong. You think you have, but you're not. And they're claiming certain concepts like God can never be grasped. But this is interesting because I feel as if we could all grasp the concept of two. If I put two apples on the table, that's all I need to do for you to grasp the concept of two. In order to grasp the concept of two, do you need to understand every single property about what two is? Right? I mean, two has lots of number theoretical properties that we don't know about. I mean, there's lots of properties that two has that we can't think about. But we can all feel as if, yes, we've grasped enough of what two is, enough properties and enough consequences of two that we can say, yep, I get it. Now, if I acknowledge what it means to grasp a concept is to not necessarily grasp all of its consequences, can we say we can grasp God? If God exists, can we grasp it? Like, how many essential properties of God do we need to understand before we're going to put it in our shopping bag of concepts which we've managed to grasp?
Well, we have to say that there's a limit in the sense that God's infinite and we're finite. So the thing that restricts our knowing the nature of the ultimate is primarily the fact that we are contained by our
But
finitude, and God is
I'm
not.
saying that I can grasp infinity.
That's right. That means, by my understanding, you are learning about the nature of God. Now, you have what you could call like a beginner's understanding. So a more advanced person would never say something like that. Oh, I have a total understanding of infinity. I totally grasp it. No.
No.
As you go
I'm
forward, you realize that the impression you had at the beginning is sort of just that. It's an impression. And it's
right.
the illumination. Like if you've been in a room that's been dark forever and then you get a tiny bit of light, you're like, whoa, this is the best thing I've ever seen. You know, it's like the people who start meditating is going to tell everybody about meditating and it's so great. But it's like, well, you could be as bright as the sun and you're in a mat. You've got a match right now.
Jen,
So
I
even the
really
sun
understand what you're
doesn't
saying there.
actually know. But the point is that even the one who is at the sun level of enlightenment doesn't make the claim that they understand infinity because it's unknowable. We can have the impression that we understand infinity. We can use concepts we call infinity in a manner that is predictive. We can predict things extremely accurately. But does that actually mean we know it in that, transcendent sense?
I
No.
I disagree. Okay, because I think that just because people are going to claim, oh, you can't grasp infinity, and I say, why not? And they say, because it's really big. It's really big. I know I'm kind of like straw man in their position there, but they're kind of just assigning a property of being ungraspable to this concept. They do it to God, they do it to infinity, right? Now, I've already acknowledged what it means to grasp a concept is to not know everything about it. I can grasp what two means. We all do, but you don't know all the consequences of what it means to be two. You don't know all the properties of two. So I can grasp two. I can also grasp infinity. But a lot of people will point at me and say, no, you've not done that. You haven't actually met the criteria for grasping the concept. I mean, this is a nebulous term, right? But they just feel as if I don't deserve to put that label on myself as if I've obtained it. I think I
It's
have. I think
very
I've thought about it
insulting
enough where I
to your,
have.
it's insulting to your intelligence for that to happen, and it's their own failure as teachers. Right, but how can you be sure how much you actually know about two relative to all that can be known about two? I'm not trying to
Almost
troll
nothing, right?
here. But
I know
what?
almost nothing about two. Almost nothing about two, right? Of all the properties that two have, I haven't thought about it long enough to know that there
It
is
doesn't make
probably an
sense.
infinite amount of
It
it.
doesn't make sense because two is a relational identity. Two makes no sense, and the two is a synthetic identity. That's the whole point with the is math a language thing. Two is a mathematical concept.
Okay,
It's
but it has relational
relational
properties.
necessarily. You cannot point to a two. I can point to a mud hut. I can point to a fire. I can point to a tiger, right? I can't point to a two. I can point to objects that have the property of two-ness, but an actual two. If I
Right.
could do that, what I did in physics, the 3+1 stuff, that wouldn't actually be an achievement because everybody would just perceive that effortlessly. And the question is, why don't they? Well, perceptual apparatus is designed for it.
Okay, so to answer your question, is it fair for me to say that I understand almost nothing about two? Would you agree with that?
What is the best, I think, would be to say you don't know. Just go in and say, I know some stuff about two. I can use two. I wouldn't use two. I would use infinity. I would say, I know some stuff about infinity. I've thought about infinity a lot. I can use it. I may understand it better than anyone else. I'd like to find out if I do. I'm going to go on a quest to find out if I do. But I can't say
Yeah.
anything about, I don't know how close I am to the absolute. So I
Yeah.
could be 1% of the absolute versus, it's like the tallest anthill. How big is it compared to the planet? It doesn't matter. It's still the tallest anthill.
Okay, but
I'm
my
only
claim is that
comparing myself to other ants.
it's the same idea for two. Like I feel as if I've grasped enough of it to like put it in my shopping cart of things that I would call understandable things. I understand what it means to be two, and it's in my bag.
Don't you
And
think it's a bit concerning that you can't point to a material too, yet you think it's real?
give me a 4-year-old, and I'll be able to teach them what it means to be two.
Being able to convince yourself of something and it actually bearing resemblance to reality, those are not the same thing. We need a means to test whether what we, that's the whole point of the conversation, I think. I want to come
I'm
back to some
struggling
of
to
the stuff
understand
you
your
were
point.
saying, though.
Okay, let's go with that.
So, intuition.
Mm.
Are you trying to think of like what we should expect for the right theory when it comes about? Because I didn't actually get to my point about the Platonism and everything. So, what's your understanding of the monad? If it's nothing, it's fine. I just generally want to know.
Yeah, like nothing.
Okay, so do you understand? Have you heard my metaphor about why a perfect sphere is unobservable?
No.
Okay, so why is a perfect sphere unobservable?
Okay, I've got my answer. I want to hear yours. My answer would probably be something along the lines of it can't materially manifest itself. And there's no way for me to even know if it has manifested itself.
You can reason it out and say that it minimizes the torque about the center of mass. The center of mass is literally the best evidence you have for particles. You already believe in particles. So you can easily reason it out that way.
Reason what exactly? That.
Okay. Just want to make sure I'm... Okay, so we're talking about intuition here. Sorry, I was reading the chat and I forgot my original point.
You're talking about spheres and how they're like sort of
Oh yeah,
unobtainable.
about Platonism. Why do I always get lost in this stupid metaphor? Okay, a perfect sphere is something that naturally happens because that shape minimizes the torque about the center of mass, which we believe
Yeah.
in. If we
Okay.
didn't believe in it, we couldn't use particles. Okay. The point is that the sphere is the template reality. But when you go to
Uh-huh.
observe a shape you know is spherical, you don't actually get a sphere because of the
hmm
observer effect. Observer effect, you
Uh,
understand?
you're saying observations somehow interact with the
I'm not
ability
saying
for
that.
this sphere
I'm
to be
not saying that.
obtained?
Heisenberg
What are you saying?
uncertainty principle is saying that. I'm not saying
what,
that. I'm just
what
repeating
are you
what
saying? What are you
Heisenberg
saying?
discovered. That's what I didn't say it. Heisenberg said it. I'm repeating it. Right? So
I want to know what
observation,
Jen thinks.
but I think it seems to be that in an absolute sense, Heisenberg wasn't wrong, and that the act of observation is equivalent to what you call eigenstate reduction and the mathematical modelization of the system, which is this idea that when the system has a particular form, not a shape, because it's pre-physical, because observation is what bestows physicality. So there's a template reality that says everything ought to be sphere-ish, but the actual
Yeah.
template is geodesic, right? But we don't want to go into that can of worms, so we just say spheres as a metaphor, okay? The sphere's real. It's not observable. So the monad's real, but it's not observable. The monad is, the sphere is a metaphor for the monad, but in the understanding classically, they had everything in that thing, like stuff like love and friendship and basically anything that we understand as meaningful is something that is not, it's beyond space and time in the sense that you know, you can't have a pet too, right? Have a pet dog, but not a pet too. You understand? Like there's no physicality to math.
Okay, can I say that back and you tell me if I've butchered it? So, okay, there's this idea of a perfect form of a sphere, but it struggles to be obtained in reality. But that doesn't kind of knock the effect of the existence of this perfect sphere. And you're
It's
saying
there,
that,
it's there, but when you observe it, the shape of it is changed.
okay, so
What are
you
we doing
think,
with empiricism? With empiricism, we're always observing. We don't have access to the template reality directly because what we have access to directly is the waveform reduction of the animation of reality. That's why I have my diagram where it's like you start with the mathematical entity of the HF8 complement, then you distort it a little bit, distort a little bit more, distort a little more, and then that series of distortions eventually is what you get to identify as like the cogito.
and how does this relate to the monad? What exactly is the monad? I'm guessing we interact with it in some
Ah,
sense, but like we can
the
never
absolute,
access the
the
absolute of
unmoved
everything.
mover. Unmoved mover, the thing that is the source of motion that does not change. I think the best metaphor, other than the sphere, which is an extremely admittedly simplistic metaphor, is just the laws of physics, the notional laws of physics, not the symbolic laws of physics. The
Yeah,
idea that
I
the
agree with you.
universe is governed by causality and that causality is immutable. So the key thing in the monad is probably the two key things are immutability and being ever present.
Okay, so it's the thing which accounts for why there is motion and stuff happening, and it's a single entity. That's why we refer to it as the monad, and it makes stuff do stuff. Is that it?
Well, think of it like the gravity equation. You know, it's a narrative, right? You think of it as God has this gravity equation, God writes it, and then the universe is on strings dictated as a puppet master of God.
Uh-huh.
Metaphor again. Metaphor.
So when you refer to the monad, does it have a mind and a will?
Well, that's the ultimate like question, right? So the idea is with the monad is that since it can't be referenced directly, it has no properties. So the question isn't what are the properties of the monad? The questions are what are the most adjacent states to the monad? What is the closest we can get to the thing? We know we can't refer to the absolute. Every time we try to, we're taking something that's absolute and we're putting a relational identity on something that's only defined in an absolute sense. So what is it to bestow language on something, to describe something in words? Well, that's relationalizing it to that language. Math is even
Uh,
more so because the
okay,
fundamental thing in math that's happening is an equation. That's a relational identity.
okay, so there's this perfect thing, and we can't really like access it perfectly, but we can kind of like dance around it by coming up with half-assed descriptions or conceptions of it. Do you think the same applies to physical reality? As in, we're playing the same sort of dance where there is physical reality out there, stuff happening, and we're just kind of like dancing around, getting kind of like close to it, but we can't really truly access the nature of it. Is that a fair summary of your
I don't want to
position?
offer an. I don't think it's my position. I'm just sort of parroting what the religions have said. This is an opinion that is like
I think you should give
shared by
yourself
many
more
religions.
credit, because I think you have opinions boiling up inside that brain of yours, and you're more than welcome to throw them out here on the stage.
Well, thanks. I want to make it clear when I am stating opinions, and as much as possible, I know people probably don't believe this, but I am trying to be unbiased when I'm not explicitly stating my own opinions. And in this case, I think it's important to be more unbiased and state my own opinions because I don't really feel like we need to change math that much. It
Okay.
already pretty much works to use the way that I want it to use. So for me to then dissent against math is sort of defeating my own purpose, if that's what people think I'm going to do. I just wanted to actually respond to everything you said because it was all so interesting. Like, oh yeah, you said something about formalization in the context of the containment there. There's this really weird myth that all manners of formalization can somehow be made equivalent. And I don't know where this comes from and if it's the Gödel incompleteness theorem or what it is, but the language thing, yeah, it's just always going to come back to that. So the questions that I want people to think about is there any actual difference between logic and math? And if so, what is it? The answer to that's going to answer a bunch of other stuff. And it's like, I'm not wedded to a definition. I can give my opinion, but if nobody accepts my authority and people are just clamoring to get on to start pissing on my authority, it's like me stating my opinion may just be counterproductive to the conversation. Maybe what's better at this time is that everyone can sort of have a chance to say what they think.
Yeah,
I don't
I would
know
love
that
to
I
hear your opinion
necessarily
as well as
have.
other people's.
Okay,
I don't
so
have a
on
well-formed
what
opinion as
exactly,
well.
though?
Mine's going to change throughout this conversation. I'm learning as I talk, which is healthy. Maybe we should put that topic on pause for a second. I'm willing to let Otangelo up on the stage, but if it gets a bit too like weird, then we'll go back to the other conversation.
Okay, I have welcome Otangelo. Thanks for contributing to our show.
A little bit to what you just said, and I basically have the same views. So what are you, an atheist, a theist? What are you?
Are you asking me?
Oh, Yen.
You're asking me if I'm an atheist or a theist?
Yes.
I feel so dang unbiased right now. I'm so happy. I'd classify myself as a very skeptical theist.
A very skeptical theist? I've never heard that description. Can you tell me in other words what you believe? Do you believe that God exists? Not? What do you believe? Who
I
is
have
that
very,
God?
very complicated opinions on God that would take a very long time and bore everyone to sleep several lifetimes over. But when I'm just introducing people generally to my views, I'll say, like, I consider the universe to be God, and my reason for that, I'm trying to convince an atheist or try to explain to an atheist, I'll say it's a mnemonic device. And it's the optimum impression scheme for thinking. So even if you don't accept the concept, certain aspects of the concept of God, I hope people will admit at least one definition due to the demonstrated wonderful effects. Just basically, don't deny yourself the good effects of religion just because you've had a bad time, which I completely acknowledge is a fact for the great majority of people. I hope that wasn't too long, Tangelo. I think you're a Christian, right?
Yes, I am a Christian. But you said that you think that the universe is God. So did the universe have a beginning? Yes or no?
In our scripture, we say that that question is the same as asking whether God created God's self, and we don't think that as humans we can speak on that due to being finite and God being infinite.
Well, I think that we can come to a logical conclusion that the universe, if it had a beginning, it must have an external causation, because otherwise it would mean that X created X, which is illogical.
Okay. If the universe is uncreated, then it's the same thing as though it created itself. And if we say it's self-created, that's just our compression device that doesn't actually speak to the truth of it. The truth of it is infinite regression, which Darth Arianis talks about quite a bit. Pretty good arguments surrounding that being unable to be defeated in a, rational sense or whatever Aristotelian sense. I'm not sure if you're following here, but what exactly are you alleging is the issue?
I am a little bit confused. Either you believe that the universe had a beginning, or it had no beginning.
Okay, it's uncaused.
What would include an eternal regress?
Right, but you're not understanding that there are causes that are atemporal. So you're saying, phrasing the question in a way that even if I agree with you in words, I can't agree with you in concept, because we'd have to go into what it means for something to cause something else and whether that necessitates temporality.
Okay,
Think of it like this. Okay, you have an argument. You're trying to say the universe has a beginning. On what basis is that argument being made? The basis of the argument.
There are basically three main arguments. One is Big Bang cosmology. The second is second law of thermodynamics, and the third are philosophical considerations.
Okay, well, the law that everything that begins ends, that's predicated on an uncaused cause. So it's a misapplication in the first place. So basically all the argument is saying is, well, the universe had a beginning, so it had to be caused. So what was the cause of the universe? It was God. Well, what's the cause of God? God's uncaused. So that's defeating your original premise that everything that begins has to have a cause. Or you're saying you're basically saying the universe had to have a beginning, but God didn't. So
well, it is not defeating
rational.
Because it is not defeating because God is not existing in a temporal state. So the problem that there cannot be an infinite regress arises when you have movement, when you have change, and when you have physicality. That's why the universe cannot be infinitely old. It needs to have a beginning. But with God, it is different, since he exists in an atemporal state, which is different. He causes time. So he doesn't exist in a temporal state. So the problem of infinity or eternal existence doesn't apply to him.
I understand what you're saying. We would consider this metaphysically unnecessary. All the things you're attributing to your entity God, we attribute that to the universe. And your inability to understand God's self-created nature is your problem, not God's. I've been through the whole logic of it. I can completely explain why, even though at the limit point it fails, it is actually irrelevant. As have a theory that converges literally everywhere but an irrelevant limit point, the best that exists right now. I do want to let this other person up, but I think that they're like, I don't want to say a troll, but I seem to remember that particular. I saw Frank had possibly a question, so he'll ask if he thinks of anything. But anyway, so Tangelo, what are you trying? Are you trying to make some version of like a Big Bang? Like that's not. Do you understand why that's not sound at all? To say, well, everything that begins has to have a cause, but God doesn't have to have a beginning.
Yes, that's what I
That's
believe.
That's not
correct.
consistent reason. It's inconsistent.
Why
so
not?
The premises of
Why
your position are contradicting each other. Your premises are being drawn from there's no cause for any of your premises. Why does anything that begins have to have a cause? Why are any of the things a fact in what you're asserting?
Yes, because nothing has no causal powers. So if the universe had a beginning, and it must have had a beginning because it is subject to change, then that means that there must be an external cause.
Listen, the way that this whole notion was developed is that within a system where causality is true, i.e., which is an uncaused cause, anything with a beginning also has an end. Anything with a beginning also has a cause. Now that's because there exists a prime cause. The only way you can derive those things is if you have a prime cause. And you're saying, I want the prime cause to be God. I'm saying it's just the universe. And to invoke God, that's an emotional argument that you can't substantiate.
Yeah, I think this is an illogical position because you're basically saying X created X. Of course, the universe cannot be self-created. It must have an external agency which caused it into existence.
You're saying, just hold on. You're saying the universe being uncreated and it was always there. Just a blob of matter, just always there. The universe is uncreated. That is somehow harder for you to square that circle than God comes in with magic powers and makes the universe from nothing and just coombs it into
What I
existence.
am saying
That's more
is
reasonable.
what I am saying is that the universe cannot be eternal because it is existing in a physical realm of change. There are three main reasons why it cannot be eternal. I can go through them, but they are basically Big Bang cosmology, second law of thermodynamics, and philosophical considerations. So there is a very strong case which we can make based on these three legs that the universe had the beginning. Now claiming that the universe self-created itself, that's illogical. That would be that X created X, which doesn't logically work out. So it must be an external cause which created the universe, which is not in time. As soon as it is not in time, it can actually be uncaused and uncreated and eternal.
Can I ask you a question with respect to that then? So, if you're saying that God is unchanging, how do you like think about that? Is he just like he's like a crystal? He's like a caveman trapped in an ice block, and he doesn't. His will doesn't change. He doesn't think. He's just a crystal. Like
I think that there was a transition. I go with William Craig's view that beyond the physical universe, God just was. And yes, you can basically imagine it like that he englobed everything, he knew everything, that he was unchanging. And also his knowledge was simply, he had all the possible knowledge, which didn't have to be sequential or something like that.
right.
At the moment that he instantiated the physical world, he got into a relationship with the created order. Then, of course, he entered time as well. So he relates with us, and therefore he is also in time now.
But if he's just some sort of crystal entity where there's no rumination in his mind, how can there ever be a moment where he causes the universe to come into existence?
I think that timeless causation is possible when you posit that the cause and the effect is simultaneous. There was simply a change where he willed the universe into existence, and that then simultaneously with his will happened, and then there was the beginning of the universe.
Okay, then I have a question. So, is the universe like a necessary thing that had to happen? Or could God have chosen not to create it?
I think that God creates out of love. Everything that he does based on love. That was his motivation.
And that was like necessary. He couldn't have like not created it.
Yes, he could have not created it. Since
Wait, he could have not created it. He chose.
Yes, he could not. Yes, he chose to create it. He could
I don't
not
understand
have
how a
created
crystal
it.
can make a choice.
At the moment that he created it, that choice was made simultaneously.
But like, okay, that doesn't make sense to me.
Maybe we can get some more people up. I see there are two hands. Tangela, you've made your point. I hope you can hear out the opposing side, because I really don't think this is compelling. Has this argument ever convinced anyone?
At least it has convinced me, and I think all those which
you're
are
using
Christians.
You are using it to bolster a conclusion you have already drawn. You are not using that to inform your opinions. You're saying, I already think this. Let's go find let's cherry pick some stuff that accords with what I already think. Don't deny it, Tangela.
Yeah, and I don't think that it is wrong to start with the presupposition that God.
It's wrong to expect that you're going to be right by presupposing that you can cherry pick things that accord with an extent bias and be right.
Why not? If God has revealed himself
not
to
how
us.
We're designed. We're not designed to be dead on correct the first time we have a flutter of an inkling of a thought about God. It takes a very long time to just get to a point where you can perceive secular things accurately, let alone the logical ones, which are far more abstract and complex.
Well, you know, Jan, I did not come to God through philosophical considerations like we are discussing
Literally
here
no
right
one
now.
does.
Okay, so I came to God actually by pain, by suffering, and it was basically blind faith. So it wasn't a recent faith, which was the conclusion of a long process of philosophical or scientific or theological considerations. It was just, let's say, a childish faith, a blind faith, where I said, well, I am suffering, I need a solution, I'll cry out to God, I'll pray and see what happens. And that's what
What
I
exactly
did.
were you suffering about?
I had depression.
And then it went away.
Well, it wasn't just from one day to the other, but I was suffering for over 6 months looking for a solution. I didn't know that it was a clinical situation, and I couldn't express myself neither to my parents nor to other people. So I was just suffering and trying to figure out by myself how I could solve that problem. And so I remember that when I was a younger child, I was praying with my mother before going to sleep. And I said, well, I'll try that out. Why not? If God exists and I pray again, maybe that solves my problem. And slowly my depression went away. I started to read the Bible. I started to have questions in regards of the God of the Bible. I was a Catholic. And then someone invited me to go to an evangelical church, which I accepted the invitation. And there I asked many questions in regards of doubts that I had in regards of the Bible. They explained me the plan of salvation, and I said, well, yes, I want to follow that God. And so I received Christ as my Lord and Savior. So that was the beginning. And then in 36 years in my constant conversation with atheists, so all these kind of objections of science, evolution, and so forth came up. And that, of course, forced me to seek answers and explanations, and that's what I am doing all along. So that's why I am saying, I think it is
Certainly not
not
cherry
wrong that,
picking anecdotes to go along with the foregone conclusion, right?
you
I
know,
gotta,
you
I'm
can
sorry, I
use
gotta
the,
put you back to the audience. But anyway, okay, who had their hand up? I think it was Chovy.
I just
When I want to say that this is Venus. Venus, the last time we talked, it didn't go well. Remember? Because I do. Leibniz, let's not go down that path again. Thank you.
just to
Go
wrap
ahead,
that up
Ulrich.
very quickly, I appreciate Otangelo's like history, his lore. I didn't know that about him. That the reason why he strove for God is because he wanted solutions to his depression. I'm happy that it worked for you. I just don't think it speaks to the truth. I'd like to ask you more questions in the future about that, but for now, let's carry this conversation on.
I'm really glad you're going to get something out of that. And, you know, I didn't mean to be rude or anything. I just wanted to keep it on the topic for this combo.
That's
So
true.
go
It was
ahead.
off topic. It was interesting though. But yeah.
Oh, y'all good?
Did you want to
We're all
ask a
good.
question? Did you want to give a comment? I mean, if you know
did.
anything about math in the context of philosophy, feel free to
I
throw it in. I don't want it to become like a
do
big
not
fight.
know too much about math in the context of philosophy. I'll admit that. Sorry for not having that level of expertise. I was gonna ask
Please don't
in
be
the
sorry. Please don't be sorry for that. Honestly, I just appreciate honesty. That's all I would be very grateful for.
yeah. In the context of philosophy, though, I was watching a video earlier today. Anti-Citizen X, if anyone's ever watched. It did strike me as one thing that was really odd about philosophy, and the sense that the academic sense of philosophy, at least for your undergrad year, almost everything is just history. Is there I guess I don't want to put this as a statement of aggression, but I feel like philosophy in the academic sense, and T-Jump, I would hopefully disagree, but I haven't seen any usefulness of just philosophy, like the general philosophy. Now there's like particulars like philosophy and math or whatever, but it still seems like we need to like move away from the unproductive side of philosophy.
Do you find philosophy interesting?
Not particularly. If you're talking about a philosophy of a certain subject, maybe, but philosophy in general is I find it a waste. Like in the study of it, like I've only taken, I don't know, 3 years of college in regards to possible courses of philosophy. I haven't done the graduate stuff, but I'm just like, I don't care for it at
Okay.
all. It's just boring.
What would you rather
Thanks for
people do instead?
sharing. Thanks for sharing. I really appreciate you sharing that.
So again, I was watching this video, and for some reason, this guy just like he, I agree with him too much. It's crazy, but I feel like the problem with philosophy is that it doesn't have like in scientific, you have a set of standards. People kind of follow the general idea. We say, okay, this is good science, this is bad science, and I'm kind of trying to repeat the ideas from the video I watched and I felt inspired of. In philosophy, I feel like a lot of philosophy is junk philosophy. Now, there's a lot of junk science too, but you know what I mean? Like, there's a general agreement of, all right, the science is this. We're trying to go to this. Now, it might be falsified or all the other stuff, but in philosophy, it's just like crap. Just
Well, hold
a
up,
lot
because
of
I
bad
would
stuff.
call the scientific method like philosophy. People had to decide what the best way to do science was,
True.
and they didn't decide that by doing science. That was like an external thing of thinking about,
true.
okay, what is
Yeah,
the best
and you
way we
have
can
to have
find truth?
the original.
So
Yeah, and I agree with
there's an
that. But
application
I
of why
mean,
philosophy is interesting. You need science. Science came from philosophy, so you needed philosophy
true.
to get you science that you care about.
But I mean, at this point, at least as far as I can see academically, and again, I'm limited, but I every time I'm like, oh, philosophers, and I'm like, well, they're not really saying anything that important. They're not like we're not making any progress. That's kind of the problem I have with the field.
Well, that's interesting because I don't know much about the history, but I imagine it has made a lot of progress. I feel like what you're kind of doing is you have this thing called science, and it came from philosophy, right?
Yeah.
Like the best ways to test things, what truth is, like how to model things. And philosophy is like the scaffolding, and you've built the building, which is science. And then you're like, get rid of the scaffolding. We don't need that crap anymore. And there you have like this building called science. And it's not going to change anymore. You're not going to question like, maybe we should be doing this a different way. Maybe we should build a different building that's better for us.
How do I put this? Not that philosophy in general is useless. I'm saying the academic field of philosophy. Like if you've looked at the papers and you've looked at what people write, it's largely junk. And I mean, like, just, I mean, I guess my favorite example is, of course, the theistic philosophy, which is crazy. I mean, you read some of those papers and you're just like, really? Like, people get allowed with getting paid for this? But, in a sense, something the video brought up and something I'm sorry to reference the video, but it just in my mind, it doesn't have a standard anymore. It's just kind of write whatever you want. If it's popular, you'll get put into the history books, but it doesn't really like have any utility anymore as far as progressive, towards some sort of goal in a sense.
What do you care about? What sort of goal would be noble enough for you to care
Well, I
about?
mean, any sort of goal, betterment of mankind in any general sense.
Okay,
I
so now we're
think
doing
that
philosophy. Now we've got to think about what it means to
Wait
better
a minute.
mankind.
Are you saying you want to live for more than just pure hedonism? I'm sorry, but
Uh,
I'm not sure that that's allowed on this server. I'm gonna have to check with T-Jump. I'll be right back.
yeah. No, just the general sense of a goal. Like put anything, just like, okay, well, we want to find more. Like T-Jump's got a really good spiel about the morality of things, which I agree. But when you look at like the actual papers on everything, it's just a mess. There's no standard. So, I don't know. I just feel like and especially in just studying, the generic philosophy. I mean, it's all just history. It's all just here are the famous people throughout, whenever, and it gets more and more like, oh, did you study so and so? No, I didn't study so and so. I don't need to study 8 different people for no reason.
Don't you
It's
want to
like,
be like reasoning? Don't you want to actually be performing philosophy and going up to people in physics and being like, bitch, please, and having that actually mean something? Because
well, it's
that's what
like,
it's supposed to be a
yeah,
philosopher.
it's supposed to be a sort of Well, see, here's the thing: is like when you're talking about science, it's like the cutting edge. You can go to the cutting edge and you say, okay, this is where we're at now. This is what we're studying. And when you go to philosophy, it's like a vague sense of, we're kind of at this point. We're not really there. Most of our, most of the real stuff is done by science now, unfortunately. So it's just like I don't. I feel
Or
like
is it?
philosophy. I feel like philosophy is this subject of, uh, well, as a field, I feel it's like this scam where people teach history. You get their philosophy degree. What do you do with your philosophy degree? You teach history, and then you can write junk papers. But I mean, it doesn't matter. Like you can, like any theistic philosophy class or teachers and stuff. What are they writing about? Nothing. They're not discovering anything. They're just rehashing old arguments over and over and over. Or you'll do Plantinga's junk, just like, oh, I created this new logic model. Cool. What's it used for? God. Okay. Did you prove God? Did anything about God? No, I made up a new system of God. I mean, like, you do that about any sci-fi fantasy junk. I don't know.
Okay,
Sorry.
so how far do you go with this? Because you can do that with mathematics as well. It's like people come up with new systems of numbers to figure out stuff. And if you're like, okay, what's the application of that? It's not going to build you a TV or anything,
Well,
right?
I mean, I would assume it does. You can
Well, it
do
doesn't.
pretty complex calculations with stuff. I mean, yeah, I mean, I guess there's mathematics that's like beyond our application right now, but you could potentially use stuff, way down the line once you get physics in line.
So this is where I completely agree with you. If there's a performative aspect to a subject, I don't like it just as much as the next person, right? I don't want people to just be faking it. I want them to be genuine in what they believe. I wouldn't go to like an artist and, say nothing you're doing right now has value, because it does. It has value to them. They're creating something that they care about. I don't like the artists who splatter paint on a canvas and sell it for $10 trillion, right? Because they don't care about what they're doing. They care about making the money, right? And just like a philosopher who just puts a bunch of jargon on a piece of paper and then, they get the paycheck because they're at a university. I don't like that either. But there are people who are thinking about things that they really care about. And there are mathematicians who are thinking about things that they really care about. There are theoretical physicists who are thinking about things that they really care about. And often you might catch a theoretical physicist admit that they don't actually care if the physics that they're doing corresponds with reality in any way at all, because
Right.
they're coming up with something beautiful. They're creating a piece of art. And you could see a problem with that they're getting paid to be a physicist and yet they're not contributing to society. But they are in some sense. They're contributing art to society. And it's
I mean,
you're just acting as if it's all
physicists,
gibberish.
well, I mean, I'm talking about the academic of philosophy. I think a lot of it is just outdated gibberish. Yeah. I mean, it would be like
How many articles have you
it'd
read,
be like
though?
it would probably like 10, 20. But
I don't believe you. I haven't. I've read like none. I've read zero. I don't think I've read a single philosophical paper ever.
oh,
But I don't think you have either.
religious papers I've read like at least 30, 50, but that's just because I get bored and I'm like, oh, what did they write for their dissertation? But how do I put this? If you want to have an academic field, like imagine if we started teaching medicine, and for medicine, imagine the medical textbooks were like, back in the day, we used leeches. Okay. Like they went through the history of like voodoo and shamans and stuff. I mean, what would be the point of that? That's what a lot of philosophy is. It's learning these outdated systems that some popular guy 200, 300, 400 years ago, 2000 years ago, if you want to go back to Socrates, I mean, or before even with the other people, but
Do
yeah,
you think Socrates was a historical figure?
I don't really care.
Okay. Just check.
I mean, I guess I don't. It doesn't.
It's
stop
okay
me
if you
either
never
way.
thought about it. You can get back to me if
No,
you're
I
not
mean,
sure. I'm still
I
thinking about
like
it myself.
it could be a mythologized person, but like it's like do you think what's his name? Do you think Augustus was a real person, or do you think, all these people are real people? It's like it doesn't really matter, that I'm just kind of like, yeah, sure, why not?
Okay, I have a counter to your point. Like in some way I sympathize with it, especially with like medical stuff. That's because there's a well-defined goal. You want to help people, You don't want to like contribute art too much, right? I'm sure there are some creative people coming up with modern ways to help people get better, but there's not too much creativity there. Whereas things like philosophy, I think it is actually important to look at the history. I learned a lot about logic, but I learned it from a modern perspective. And so you get this really one-sided view of what a subject is. What logic is to me is something really narrow. And only recently, I looked back at previous systems of logic, and it's broadened my mind on what logic can mean. If I was to create my own system of logic now, I have more tools in my arsenal to create something exciting. I think learning about history is really important when it comes to philosophy, because it is about thinking of new ideas. And the more ideas you can see, and the failure of certain ideas is an important thing. You look at ideas and you go, this failed because of this reason. You don't just want to look at the modern ideas. Of course, in medicine, you just want to help people get better. But maybe it's also good to look at the failures. We tried this, it didn't work. Don't do the leech thing, it's crap. Don't stick a pigeon ass, on a boil. That doesn't work. So, but you need to look at the bad ideas, because they still have content. Just because something has a mistake or didn't quite work out doesn't mean there isn't something to value there and something to springboard off onto to get some real new ideas.
Right. I would agree with you in a sense. I mean, obviously, learning that leeches don't work for, all the diseases would be useful. But in the same sense of philosophy, there is just so much junk. I mean, 90% of, I would say, an undergraduate career is history. It's not really application. So, by the time they get there, and then you can look at all the philosophy papers, how do I put it? Once you get into that realm, you're just like, well, I get, who's gonna really read it? Who's gonna care? Is there any criticism? Is there stuff like that? And it doesn't really matter anymore because there's no standards in philosophy. It's just people writing whatever. They don't really, I mean, as long as they're popular, they get their stuff done. Just like you see like a lot of people with the self-help stuff, like Jordan Peterson and other people like that, they get a lot of funding and stuff and a lot of attention, and they become a huge person in the philosophy community because no standards. You just got the same kind of if it's popular, sure. And in the same sense, I guess you could go for science, but I mean, you can always reference things as fact in science. So,
Well, what do you study?
what do I study?
Yeah.
I study computer science.
Okay. So that's like quite like a rigid subject. Like your program either works
Well,
effectively
yeah,
or
I
it
mean,
doesn't.
you could do theoretical stuff with AI, but I'm not doing that. So I'm just saying that when you get into the philosophy thing, and I've taken like a couple philosophy courses, it's just like, okay, we're doing the history thing again. We're learning about stuff and what so and so thought and what they taught. All right.
Okay.
Yeah.
Well, as a mathematician, I'm forced to be in this perspective where I have to defend against utility. Right? I am fine with thinking about things that have absolutely no application in terms of like making people happier, making people healthier. I don't care. It does actually make me happier to think about these abstract objects, but that's not my goal. It's like an adventure, and I feel like it doesn't just belong to mathematics; it belongs to art. And I used to think of mathematics as closer to computer science. Now I actually see it as closer to art in a real way, because there is a massive creative aspect. You create the formalizations to think about the ideas that you care about. You create the stories behind the objects as to why they exist or why it works the way they do. There's no actual story, but you create the stories. And it's similar to like chess players, how the best chess players tend to be intuitive people, where they're really good at speed chess. They can do a move, they don't do any calculations, they just play the right move. I'm not even sure what's going on in their brain. It's just an analogy, but they can do the long calculations if need be. And it's the same with the best mathematicians. They're really, really creative. They have ways of compressing a large amount of information into a small idea or feeling, and then utilizing that. The things that excite me the most in mathematics are the most useless things. There are a bunch of questions that I have in my head that I don't have any answers to. For example, why does the dodecahedron exist?
Wait a minute, your definition of utility is now to shit on utility? Love it.
What?
Well, I don't know. I just
Sounds like an argument from idealism.
I would think mathematics would be probably the most utility, but if you're going like, I don't know where you could say mathematics doesn't have utility, but it's interesting.
Anywhere it doesn't get implemented in practical
Well,
terms.
yeah, you could say like, oh, I can't use this equation and our abilities, but you could use the equation theoretically, and that's kind of the point. Like, I could calculate.
Well, then utilitarianism is meaningless, right? I'm saying this, so.
I don't know.
It's kind of like there's an
utilitarianism is
old
not
man
the
and he
same
plants a
as-
tree, and the tree grows into this big oak tree with lots of fruit, right? And people come about and they pick the apples and they eat it and say, "Thank God for the old man who planted the tree." He didn't care about feeding like hungry orphans like 100 years later when the tree had like bloomed.
Right.
He just cared about like looking out of his window and seeing this tree, right? And then he
but
died,
I'm
and then
saying
it
that
fruited
you
up.
can. So the kind of the difference I'm saying is that mathematics you can check. You can say, okay, does this work? Someone else can verify it and say, all right, that's
That
good math.
doesn't mean
it
the
works.
interpretation is right, though. It means the
Well,
interpretation gives information. There's a difference
Yeah.
between gives information is absolutely correct. I'm not saying you're making that category error. I'm saying it's a very common category error that I want to chirp in for.
Yeah, but I'm just saying as a general whole thing, the point of mathematics is that multiple people can check. They can do that sort of verification. They could say, okay, this is good math. No,
So do you see why that's a
too.
weakness as much as it is a strength? Because you can hypnotize yourself into thinking it's right, even though you're maybe assuming it's right on a level it's not.
Yeah, but I'm talking about just base standards here. I'm not talking like, I'm not saying like, a lot of people can't just go along with it and they're like, oh shoot, we made a mistake, later. But
no,
as far
they
as
can't
the
do
difference,
that. No. I understand the difference in reasoning that when we are talking about, if you're looking at a thermometer and you're saying like, is 30 hotter than 25? That's completely uncontroversial. Whereas if you're discussing what is temperature absolutely, it's a different class of question. Arguably an unanswerable question.
what is temperature?
The notion is, what is it that we need to have temperature? How many other things have to exist so that we can define temperature? It's not something that is the same type of question as, is 30 degrees hotter than 25? Like, you can answer the 30 hotter than 25 very easily. You can't answer what is temperature in an absolute sense. I mean, it's not even clear how to start to answer that question.
Okay, let's make it concrete then. So you're saying mathematics is kind of neat because you can get a group of people and they can check the maths and see if it works. Whereas for philosophy, you can't do that. I mean, like, they can take a piece of philosophy and they can all look at it and they can go, oh, it's okay. But there's no like objective standard to test whether something's like a good piece of philosophy or not.
It's not just that. It's not just like people go, oh, okay. I mean, it's just like the Wild West. There's just everything. There's everything. You can do. It's about
They
anything.
do, though, Euler. It's the Socratic method. If they can disprove based on, the reasoning of the Socratic method,
They never
then it's
have
supposed to be irrational.
question. They never have the challenge. You can read like a bunch, theistic ones the best, but you can reach a bunch of stuff. So, anyways, I encourage you to read any famous person for theism, any philosopher. Go read their dissertation and just have a laugh. All right, I gotta go.
I'm going to have a look and see. I think Shawniosis. I'm sorry, there was somebody else that did want to come up and we didn't get a chance to talk to them. So, welcome, Shawniosis. Did you have a question or comment? Thanks for joining. I see you're muted. I will invite.
Is that better? Can you hear me? Okay.
Coming through loud and clear. Welcome. Is this your first time chatting on a stage?
No. So no, I was just as confused as you were if I was actually muted or not. I just felt the last guy was quite naive. That's what I more wanted to talk about. It's like science, physics, natural laws deal with empirical evidence, and maths and logic deals with proofs. So I didn't really get a lot of what he was sort of implying.
What do you think his point was?
So what do I think is pointless?
No, what do you think his point was? What do you think he was trying to say?
I think he has a very, very high percentage of belief. There's no justification or reasoning.
But what was he trying to say?
That yeah, God exists, and it was of a specific religion. And don't get me wrong, I'm a bit of a pantheist, deist kind of like person, but completely wrong way. He just had a full 100% on belief.
Of what? Who are you talking about?
The guy that was just on before, sorry.
I don't think he believed that God exists.
I think
saw
Sean
that he
Eosis
actually
was saying
made
that he believes in
statement.
God. That guy's an atheist, I'm pretty sure. I mean, wasn't he saying that he yearned for better philosophy tools?
Yeah.
That's what I got from what he said.
Yeah, it was cringe listening to that. Philosophy is, shit, basically. No. It's the whole entire scientific method. You can't, you
Philosophy
can't
being
discern
shit and science being
philosophy on
shit,
any.
those are not contradictory things. They can both be true. It's not saying they are.
No, no, exactly. No, I'm agreeing with you. I think philosophy is a very big and required stepping stone for science to exist. And he kept saying that, no, I think science is this. And it was like, no, philosophy creates a scientific method. It's how you determine results. It's how it doesn't gain knowledge. It just justifies what you're experimenting. So it was just, I don't know. Yeah, it was a little bit painful to listen to with the last guy. But yeah, I mean, my self sort of position, if I may, is I can't justify materialistically or through physicalism a result. So to me, mathematics, logic, if there's something else, a consciousness that is separate from anything I mentioned, yeah, but that is a belief, on my end. I just thought that a lot that what he was saying was just, yeah,
So,
it was
so you have
kind
a
of
belief in a
irritating.
pantheistic. You have like a pantheistic position. So,
Or more like a deist. It's like, fuck something and fuck off sort of thing. I know that sounds really bad when you saying it like that, but I don't believe that, like, for example, like we have a macro level understanding of physics. We have quantum mechanics. Why doesn't it get bigger? Why isn't it smaller?
I'm struggling to understand your point.
Yeah, I'm like bigger, smaller. What does that mean? Like, why isn't it right enough? Kind of thing.
No. It's got nothing to do with our universe, but we're created from something. Not as,
How do you know?
by the way, we exist.
Okay.
And this isn't, no, I don't know that my parents created me. I think it's Jesus or something. That's not my point. It's just there is something, there's a cause. If it relies on physics for something to be present. mathematics is required to carry that out.
Mathematics is
There's no
required for what? Sorry.
reason mathematics is required for physics.
In what sense?
Dimensional mathematical structures for anything essentially to exist would require mathematics. It has to have a number. It has to have some form of code that.
That sounds like wishful thinking with no justification. And this is why I have a quote of myself that I like to say as infrequently as possible is numerology is the first step towards insanity. People have gone nuts looking for those numbers.
Not if the
You
question's
want to say,
not been
there's so
answered.
many numbers in the universe. It's like, is there? Why are we so sure about that?
Okay, I don't think
Yeah, but
mathematics is required for physics.
Oh, that's another real good
So
question. Is whether that's true.
any physical thing doesn't require mathematics.
Yeah, that's what I'm saying.
Yeah, but it cannot be backed up.
It's an
Empiricists
abstract.
cannot back that up with any evidence. So you can say that, but can you back it up with an example?
The reason why I say physics. Wait, hold on. I've got a point. The reason why physics doesn't depend on mathematics, Sean, is because you're confusing. Like, okay, physics is the stuff that's happening out there.
No equations are required.
No equations are required for stuff to be happening out there in the universe. If what we're going to call mathematics, which we already talked about at the start of the conversation, if we're going to call mathematics equations and formalism and all that stuff, I don't think that's physics is required. You don't need formalism for planets to orbit stuff. Mathematics is our description of planets orbiting stuff. Right? We can come up with an equation and make predictions and stuff like that. But whether we can formalize it or not isn't going to change the fact that the planet's like doing its thing. Right?
Okay, all right. So, for example, any equation that explains a force, like a law, like thermodynamics, is that required for physicality, or is physicality bound by an actual explanation of why and how and if it happened?
Okay, so if
in
I'm
other words,
correctly,
it's like thermodynamics. Did the law through nature require a number that physicality takes and works towards through physical natural laws, explains momentum, energy?
Okay.
You have to have a number. You can't just say a ball of stone is gonna, or a physical thing of matter is going to end up here without a direction. Why is it going to go that way? It has to be explained by numbers. It's as simple as that.
But there's an issue, right? It's because
you're arguing
it's
your
proof. Listen, Sean, you're talking too
and
much.
a law.
Sean, calm down. Is the equation prescriptive or descriptive? Does it describe what's happening or does it prescribe it? And how would you even tell the difference?
Then that's a probability based.
What do you mean?
So you measure what's right and what's wrong out of. You and me both know that you're talking about quantum mechanics here, and that can't be measured.
I wasn't talking about
quantum contentious. Let's keep it chilled out. We're not secretly trying to engineer anything in this combo. We're just trying to get a deeper understanding. That's it. Welcome, Sigma. Thanks for joining.
Look, I wasn't thinking about quantum mechanics, by the way. We can go there if you want. I was actually thinking about like general relativity, something big.
I'm always thinking about quantum mechanics, so I'm sorry, but that just doesn't mean anything that I'm thinking about it now.
Well, okay, look, I was thinking about planets. That's honestly what I was thinking about. So we have planets, right? And we can have an equation that predicts their motion, and we can check if our predictions match with the equation. We could do that. And let's say that our equation is really, really good. With any degree of uncertainty, our equations perfectly model what the planets are doing.
Yeah.
It predicts their position just fine. Is there a way
Yeah.
that you can tell if your equation is just describing what's happening or prescribing? And is there even a difference? How can you tell?
Are you questioning like literally a law on a macro scale?
He's
I
asking
guess
how you
maybe.
understand it to improve his own insight. That's all.
So you're saying it prescribes it. You're saying that
okay, a planet or a black hole or whatever it might be, does it require quantum mechanics to fuel and carry the planet?
I don't know, maybe. What's your point?
Right. So, okay. So, is there a measurement process that's different why quantum mechanics and general relativity doesn't combine?
I have no idea, but I think you've dodged
measurement
my question a little bit here, Sean.
I'm trying to explain. So, a measurement process on observation of a macro level planet,
yeah,
doesn't apply to quantum mechanics.
It might, but so what?
Well, no, it not might. It does.
Okay.
Fusion
So what?
keeps it. Well, what I'm saying is that any interpretation that you've gained does not essentially gain a perfect one answered question. Answer.
Okay, Sean, I want you to answer my question as best as you can, and if not, we're going to have to move on to a different topic. So my question is, do the laws, the equations, do they just describe or prescribe? And I think you said prescribe. And how can you tell the difference? Yeah. How do you know they're prescribing and not just describing? And
describing is observed and then measured.
But that would fit with the description, right? Like my equation, I look at it and I measure it. I could also say the same.
Belief, and then it's measured, and then it's measured as a law.
It's a belief. It's a belief. What do you mean?
Of course, it is. Knowledge is a subset of belief.
Okay, I'm struggling here, Sean. Like really. I'll leave you that to think about. Okay, does it prescribe or describe? I think you should think about that because it's not obvious which way it is. And if you're saying it's prescriptive,
yeah, exactly.
I think
it's
that goes against what most physicists think.
How much does it predict? I'm sorry, it's a question of how much does a theory predict in advance of observation. It's a huge, important distinction, right? If it's descriptive, it doesn't necessarily predict anything. If it's descriptive, it predicts more. Or am I understanding that wrong?
I'm not sure. I
thought prescriptive was more predictive, as in it tells you something about what the norms are versus just what's there.
Let me clarify my question then. So if I'm saying if we have some law, like Einstein's field equations, if I'm calling them prescriptive, I'm saying that reality kind of does what it does because this equation holds. This equation isn't just something that we've manifested to describe what's happening. This is how reality is happening, and it acts because there is something that's restricting it. The equation tells it what to do. It prescribes it. The counter to that is, no, we've come up with the equation. It's descriptive, and this equation could be wrong. We could keep coming up with better and better equations. We have Newton's equations. They kind of worked. We came up with Einstein's field equations. They kind of work. And people are coming up with newer stuff all the time. So my best guess is that there maybe isn't, like, we're jumping around from model to model. Can we ever find a model that's like perfect? And I'm not sure we could even know if we found one or not. So
you
it seems like
what it means. You have to define what it means to be perfect. We say we have acceptance criteria of perfection, just like with the Leibniz thing. What are the Leibnizian criteria for equivalence? Okay, what are our acceptance criteria for perfection? Then we go looking for it.
That's interesting. We could bring up that topic later. I want to hear what Sigma has to talk about first, though.
Sigma, welcome. You are actually about 10 dBs lower than everyone, I think. Correct me if I'm wrong, Euler.
All right, give me.
No, I can hear him just fine.
Volume.
Maybe you've turned him
I
down.
can hear him fine too, but I think he's at a lower level than both
Oh,
of
he
us.
sounds same level as you
Okay.
to me.
Yeah, it sounds
Excellent.
good.
Jen, turn up
Could
your
be-
volume.
He's
Hey, nice to
playing
meet
loud
you guys.
enough to hear.
Good. I can turn it up. I would set a little lower.
No, you sound
If
brilliant.
you wish to, don't go too far.
Okay. Okay, gotcha. I'll leave it where it is for now.
Yeah,
Good
I wouldn't
combo.
mess with it.
Kind of hopped in the middle there. So God, you guys cover a lot of stuff. You go off a lot of tangents. So I guess I'll start with the easiest thing for me to recall was the idea
Welcome
of
to the T-Jump server where we tangent.
So you were discussing whether or not equations are equivalent to phenomenon. Is that correct?
Yeah.
Okay. Well, I'd have to say that they're kind of understanding what equations are, which they're again equivalent to currency, we could say, right? It's a representative function, right, for something that actually exists.
Mhm.
In of itself. So does it's kind of understanding. Most people don't have a depth of a super an in-depth knowledge or into a comprehension of what equivocation actually means, right? To really understand that metaphysical construct, right? So in my play, I would say that it is equivocating, right? Because we can see some of the things that equations require are conjugation, right, and integers, which those concepts in themselves are very inclusive, right? They really represent anything. So some of the argumentation I notice is like, does the actual equation, like the the number one, the symbolization, right, the icon, and the written syntax, are those one and the same, right? Well, it's like thinking about money. Does money, is it actually an apple, right? Is it actually an orange, right? Is it either of these things? Well, it's just understand that they're functionally disassociated, but represent an absolute phenomenon. So, I was wondering what you thought about that.
No, that's really interesting. I've never thought about like money, like sort of being equated with like objects that you can purchase. It's kind of interesting. There's kind of like a paradox there though, because the value of money can change. So like, are the two objects like functionally the same? Well, not really, because I could have $1 in my hand. That's a token for an apple. Let's say an apple costs $1, but the price of apples could raise, and so there's like a movement between what the token's representing and the thing I want it to represent.
That's right. Because the apple or the orange can be equivocated differently. You can assign a different number value to it, right? The dollar, the number, stays the same, but how much you can purchase with it, that changes. So
So
it's
I
like
would
math.
say that
One is always one, right? I would agree with you on what you said earlier. That can you know what one is, or you said two.
One is
Like-
not always one in math, though. Like there's a bunch of different ones in math. There's like the identity matrix and so forth.
Yes. Well, I meant, that's like the field of computation. Like you have basically an infinite amount of sets you could possibly process, right?
You could think that, but then you get a self-reference problem, right? And you can't solve higher than x to the fourth because reasons.
Self-referencing problems, that depends on whether referential things are a problem in the first place. That's a very
Well, it is a
interesting
problem,
assumption.
isn't it?
No,
Isn't it?
no, it's an interesting proposal to say that it's a problem. It's a big assumption, right? Like ideas of non-contradiction.
It's
Like
one
why?
of the trilemma. Blah, 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 trilemma or whatever the heck it is. Isn't the self-referential circular reasoning supposed to be a bad thing?
I've noticed that was an interesting assumption, right? Like why is that? It's like the idea of a tautology, right? Me and Jen have discussed this before, and often she's scolded me for this and saying that tautologies are trivial, right? And I like to say that
They
our
aren't,
tautology.
though. That's actually not true, though. Not what I say. You're spouting off things which are vacuous, is what I'm saying, and that's not the same as a tautology. For something to be trivial is not good, but for something to be vacuous is even worse.
What's the idea that of something being vacuous? Is vacuousness essential, right?
I'll
in
give
the
an
place
example. You know, when we trust Jesus, we not only place our faith and see light in him, but consequently we see light in ourselves. Vacuous. That type of thing. Doesn't further, there's no furtherance of any understanding by speaking that type of rhetoric. That was my point.
Say that one more time. One more. Just let that soak in a minute.
Speaking that type of rhetoric, you have to control the frame. You have to control the confines of the conversation to ensure that order will increase, because entropy increases spontaneously in the conversation in any situation. So you have to say, okay, we have to impose these things that we know that the energy of the conversation, which normally goes down, well, because we put this, you know,
that's interesting. Yeah, framing is an interesting concept because when taking like meta concepts, it seems to require a notion of deconstruction, right? You're trying to disassemble a frame to discover a framing that can encompass all possible sets of frames, right? So in the process of me framing, right, I have to like analogize it to something very specific, right? Very defined, a well-defined notion or context, right? But again, the process of deconstruction makes this rather amorphous, right? Because we end up talking in generalities, right? Like Jen, for instance, talking about the idea of the universe being what do you call representations of the sphere, right? More akin to geodesics, and then further Platonic shapes, right? It's the sphere is very generalized, right? It gives only really 3 different types of variables that make up a sphere.
It's actually a specific example of a geodesic.
It is, but it's very simplistic object, right? Because it only has 3 variables, right? It has position, or orientation, vector, and boundary, and that's it, right? And you're trying to use that simple construct to build larger, more
I'm not.
intricate.
That's the thing. That's not what I'm doing. That's not what I'm doing. I'm using it as a metaphor for a much more complicated concept that is absolutely 100% inaccessible. So the question is, what is the best metaphor for the monad, which is something I tried to bring up twice now, which hasn't actually landed due to how abstract it becomes and how hard it is to actually keep things on track when it goes in that direction, but it's fun.
I don't believe it's abstract. I believe it's actually really obvious, right? It's just been overlooked, right? Because of this idea of kind of disassociating from its obviousness, right? Because I don't know if you knew this. Euler, is it?
Sure.
That the monadical observation is really the tautology of experience itself, right? As far as the philosophical notion, the metaphysical knowledge construct, right? It encompasses everything, right? So in Jen's model, which is a really great work. I always got to say that to Jen. That it like she was noting right now. I guess I'll go into that. The disassociation between the she says that you can't know like the perfect form. We can't know the perfect sphere. I'd disagree, right? Because the notion of imagining,
we can't observe it for literal physical purposes. I didn't say anything about knowing it.
No, well, observe it. Yeah, we can observe. We observe it right now. The minute I think of it, this is where I would go to Euler's point. This is what I was trying to bring him in. Was the idea that the thought itself is a physical process, right? It is physicality. It may be a diluted or gaseous form of physicality, but it's still physical, in my humble observation. And that there's a distinction. Earlier, the other gentleman who was about God kind of brought up the idea of a term you guys used, a conflation. I thought, correct me if I'm wrong, is the idea of what is real, right? And what was the comparison? Real and help me out here, guys. I'm trying to process this.
Okay, I think I don't know if I'm touching on what you're throwing out here, but there's like things which are real and there's things which like have content. and there's like a dance between the two of them. So if I want to think of like the perfect sphere, in what sense is that real? Well, it's not real in the sense that it can be manifested physically.
It's not
But it has
physical,
content.
but it is real. But it is real.
Are we
That's-
willing to
that's
call
what
it
I'm
real
getting at.
though?
Well, real is if it exists,
You're
right?
saying it feels real
In what
because it
sense?
exists because it's something that's intuitive to me? Like, is that
No,
anyone
because
gonna be? Is
well,
anyone gonna buy that?
like for me, the real idea of real is just experiential, right? It's real. It depends on the state of realness, right? Which can
Okay, then Harry Potter's
seem
real,
to
right?
vary. It is real, but it's real in a platonic sense, right? It's real in a
Okay.
the construct, right? It exists as a series of ideas and thoughts which are still bound in the physical world. Would you not agree?
But maybe we want to like distinguish between things which are real and things which are just real then.
Well, that's what we use the word physicality, right? Physicality, metaphorical.
We're supposed to
right?
define
Ideal.
real in a way that is actually uncontroversial. You don't just
Yeah,
want
because
to
if
kick
you
kick the can down the road. We want to put a
Why,
finger
well, why
on what you're getting at.
uncontroversial? Uncontroversial is interesting. Well, why would I want to do that, right? There's a lot of controversial ideas, right, that become,
Faith.
you know,
Faith is easiest in things that are uncontroversial. So groundedness, ultimate groundedness in something uncontroversial is rational because it's easiest.
it may be rational. I would agree with that, but rationality isn't the sole modus. I mean, you've got, the logos, you've got the pathos, and you've got the eros, which is the rationality. Picking rationality requires a specific goal.
Just
And
skip
that's
to the actual point without this flagrantly irrelevant meta-analysis, please.
flagrantly, well, that's your opinion. Does anyone else have that opinion before we?
And we all know what they say about my opinion. So let's go to an actual thing on the subject here.
Okay, I mean, if you're modding tonight, Jen, that's fine. So, yeah, I mean, that's basically where I was kind of going. This kind of flowed, went off tangential, but I was trying to like hit all the points. There's a lot of really good points of interest. You guys brought up some
No,
good stuff.
I think you tied it all together quite nicely. I mean, just to bounce off what you just said there, to distinguish between things which are like physically real and things which are like real in a different sense. I don't know if I want to play this sort of word game because I then end up committing to like pretty much anything being real that I can conceive of. And even not just like perfect things like a perfect sphere. I can conceive of a perfect sphere in some sense. Maybe I can't capture all of it, but it feels as if it's there. But there are also a lot of imperfect conceptions that I can conceive of. And it's like, do I want to grant them the quality of being existent as well?
Well, it's not without, I would say, not without specificity, which would be like, how is it, right? It's like, okay, it's real, but it's real in this sense, right? It's ethereal. It's translucent, you could say. And that's okay, right? It still distinguishes it, right? But it also puts it in context, right? That it is something that exists. It is phenomenological. Phenomenons are things, right? I mean, to discount anything, from my opinion, from our experience, would be foolish, right? What we want to do, what I would like to do, is account for that which I'm experiencing, not discount, right? Discounting is a function
Proper
on goal.
accounting comes from proper discounting. That's a zeroology.
Yeah. Oh, yes. But like you said, it's utilitarian. I have to have a goal, right? And then I can start discriminating. It's like the idea
Did
of
I say
debate.
it was utilitarian? Oh, that's right. Oh, good. You actually did listen to that one thing. Thank God.
Yeah. Well, it's not inappropriate, right? Like it's the idea of debate. Debate is rather useless without a goal, right? You need, which in this case
I
probably
actually
be like truth.
disagree with that kind of because I'm not. I said utilitarianism was unfalsifiable. I don't think it's really the supreme truth, but that's a different story.
I don't think it's a supreme truth. It's another element. See, like that, we're kind of picking between the dichotomy, right, or dichotomous elements. It's like, why bother? Why not just figure out how they're congruent, right? How they interplay, rather than
I bother to be right.
to be right. Right.
Like,
Well,
I have
again,
this wonderful dessert I just prepared. Well, why don't we just mix it with some shit? It's like, well, maybe I won't.
you could see that,
You can see why I wouldn't be too eager to do such a thing necessarily.
Yes. That's again in a very specific context. Okay, you're right in that context. Could you be wrong in another?
Burden
Right.
of proof is on you to make the argument, not speculate like a dick and ruin
well,
the show.
no, it's just like that.
Math and truth and logic, things that I actually want to talk about rather than hypothetical Meta-analysis, not the place for it.
Well, it's
can I?
hypothetical.
Okay.
Okay, go ahead, please.
So, you made it sound. I don't want to mischaracterize you, but you made it sound as if like any conception, you're gonna grant it existence, and then it's like a marble block, and then you're gonna come with your chisel and like chop away things which you don't think should be there, right? Like there are going to be fuzzy concepts that you don't really want to call
see right
existent.
here. See, you're giving me like I like this, like maybe this is an overconflation of agency, right? Because it's not me granting, it's just an observation, right? These are things that are happening, are they not?
But where does your chisel come into this as well? Like, do you like
Well, like
smack
my
down
chisel,
some ideas?
my chisel, I guess we would say, would come into, well, as I'm abrading into these strata, these substances, these substrates, right? They interact with them differently. So, like,
Okay.
like when you encounter something that's ethereal, that's imaginary, right, on that end, because it doesn't, you know, it doesn't push back, right? You can push right through it. It stays. It has an intangibility to it,
Okay.
right? And please.
Right. So it's not so much like chiseling away. It's more like there's a big block, and you're kind of just like, like you're creating borders for countries, chopping it up into different regions. Like, okay, these are the things which are like the real physical things. These are just like intangible conceptions. They still exist in some sense. It's not like you're like getting rid of things.
Yes.
Is that right? Okay.
Yes. Right. Just to count, organize, and know that the system changes, right? As we know, some things that remain unrealized can eventually become realized, given the right context, right? So context changes, and so does the possibilities, the potentialities. So math is akin to this, right? I'm sure you sound like a man who's probably familiar with Wolfram. I know Jen is. Yeah, love Wolfram. Watch him any chance I get. And he's kind of showing that, especially over the last few weeks. Talking about truth claims, right? And these we call it kind of a measure of indecipherability, right? That requires like that every truth claim kind of manifests always in context, which is obvious, right? It's like, yes, of course, because that's my general experience. Is that
Whoa. How is that obvious, though? Seriously. I agree with you, but why?
well, obvious from general experience. Christmas just came up. How about Santa Claus, right? There's a nice claim, right? That didn't line up with reality, right? It had tells, right? Oh, like the presents came out, the cookies were on the
So all statements of
banister.
fact are circular within their axioms. If we let languages be a set of axioms.
Yeah.
We have recursive sets of axioms. We can define multiples on there, and they're not equivalent because they're happening simultaneously.
No, they're equivalent, but they can be. It's all we can do is
It
equivocate.
may be structurally,
what I'm
but
talking
not
about.
functionally. You can never establish that they're functionally equivalent because they're operating simultaneously. As I've been repeating, and I can't believe that this is controversial, right? Like, can math exist without language? It's like, I understand the universe has, like, quote, something, mathematical, symmetrical about it, but that's prior to math.
Well,
Math is, what we
that's
understand
right.
as math is necessarily includes a corpus of symbolic representation.
That's what I mean. You're right. Math, as defined as that, as a symbol, as humans' math, symbolic representation. Yes, but is
If you're using a
computation?
computer metaphor, you have the computer, and then you have an additional program that you're putting on. So the computer base operating system, that's analogizes the natural language, and then these other programs, that would be the quote, I called it synthetic language. I called it a synthetic language, which caused an enormous amount of controversy, more than I thought.
I think I would
see my
agree with
logic,
that.
right? Quote unquote.
Yeah,
You would?
yeah. Synthetic. That's true. But is it representative, like, of the function of a math equation? Math might be our symbolic construct, but it's the computation. Is that inherent? That's a question for everybody. Is the conjugation, to use a verbal metaphor, is that inherent? Not the words, not the symbols, but just the speaking, you could say.
I don't think I actually understand what you're asking.
Yeah, I don't either. Can you?
Well, that because math is a more constructively universal. It's the universal language, right? That's the equivalent, right? It's been used. That
That's a claim, but that's not a claim with a whole lot of evidence. You can say,
Well-
well, it's actually computers. It's actually increasing density of transistors. It's just brute force in that. It's not actually any deeper insight on the level you're alluding.
No, but the conjugation, the shape forming, the geometry. I said this word. The geometry. I don't think I can say it right now. Geometrization, is that a word? Right, the forming of
Well, what do we mean?
process of
Are you
form.
saying the association of a form which is geometric in nature, fundamentally geometric, association of that to another concept? As a metaphor, like
the manifestation of the form.
some
not
words
form,
don't make sense to make.
right? They might not.
Understand? Like I'm not sure that
So
this
I'm talking about
concept actually exists.
the manifestation of form, just like in an equation, right? That there's the process of going through the form, the computing, right, of the equation leads to a shape in the end, which is usually the result, right, the solution. So
Okay, so I think this brings back to like my analogy with the pond and the bird watching. Is like, I think a triangle exists beyond the description of a triangle. I don't really like the word computation because it kind of makes me think that there's some sort of movement occurring. And I kind of like to think of these mathematical objects as being like crystal. But let's just like think about a triangle. Okay, a triangle exists, and I can formalize it in different ways. I can talk about triangles in loads of different ways. And each way of talking about it gives me some insight into the thing that I care about. So it's like the pond is the thing I care about. That's the triangle. And the little bunkers around the pond, they're like ways of formalizing what a triangle is that gives us insight about the object. I don't have to like commit to the existence of an actual triangle for me to feel like I've gained insight about the object. It could be a complete fiction and there could be no triangle, but it doesn't feel like that because just like how we can have different languages for words, I'm sure the word happy, there's lots of different ways to say it. And maybe in languages, they kind of like the word happy isn't always exactly identical in each language, but it's kind of roughly describing this conception of happiness.
yes,
So too is the formalizations of a triangle. They're not all saying the exact same thing. I don't agree with what Jen said before about all formalizations are equivalent. I don't think so. I think they can say slightly different things.
I did
because-
not say all formalizations were equivalent.
Okay, sorry
Never
to
mind, I didn't say that. Sorry.
mischaracterize that.
I was trying to frame the question so that we could see why we had to accept certain definitions in a fixed sense in order to progress, get more information out of it. I hadn't actually committed to any definitions necessarily.
Okay,
I
don't want to put
would
words
agree.
in
I would
my
agree
mouth.
with him. I think that it'd be like the idea of a pyramid. You know, like I think it's an orientation issue when it comes to language, right? Depending on where you're looking at this object, right? You can describe it differently, right? You turn a pyramid, right, in different angles, and obviously you're going to get slightly different descriptions of the same object. I'm interested though. You did say that you don't think that you don't like the idea of processing, right, or movement, right?
Yeah.
Because you said like triangle, right? So when you said triangle, like, well, why not just triangulation itself, right? That's the platonic form of the triangle, as maybe like the Neoplatonists would say. You know, that it's a processing, right? Well, I was curious, what would be the your analysis of the idea of that it's more of a processing than an actual shape, a shaping rather than a solid shape, right? Not an equation, but an equating.
Okay, so I'm not. This has probably got to do with like my background and how I just like thought about mathematics, but it's really helpful to think of these things as being like fixed, and then we can put like moving pictures on top of it. Like if I want to think about a triangle, maybe I'll think about like drawing the points first, and then I can join the lines up, and there we go. I've got a triangle, and that can give me some insight about what a triangle is. But the whole movement aspect to it is just me. It's me doing that.
Well, that's what I mean. It's just like money, right? And money. That's why I use that. I use that analogy, right? Because it fits very keenly. The money, as it said, the unit doesn't really change, right? It stays the same, but it's representatory of everything that could be a dollar, represented as a dollar. Right? Just like math, right? It does the same thing. Like, yes, I agree with you that it does require a fixed point, just like money, right? It's a fixed denomination. But outside of that, it represents anything right? Everything, potentially.
So when it comes to movement, are we like bringing this in to the picture because of like Wolfram and it's like the universe is doing computation? Because I would say that's physics. I would say what Wolfram is talking about is not some sort of crystal structure. It's a dynamic system that changes over time. So it makes sense that when he says that the universe is computational, there is something that's like doing something. Whereas when I'm thinking about the abstract objects, I want to make sure I've pushed them into the corner of crystal things that don't change.
Why? Why not just consider it just a temporal reference? Right? It serves you in the moment.
What do you mean?
Well,
Okay, so
in that it's like I said, it's an arbitrary assigning of a value, right? That's what it is. I mean, what he's showing is like, again, maybe not the crystal, right? Like you want the solid form, but he's showing the crystallization, right, of these computations, right? They're forming structures, and that's the thing. Is like it's the idea. Like I've noticed that people have their comprehension is possibly highly curated, right? And that it was very easy for me. Me and Jen have discussed this. It seems to be very easy for others to just accept that that the universe or the reality, all of this computation, mathematics, is all just a series of movements, but movements in representational space, right? You have to have an orientation in order to exist, really, right?
Ironically, he thinks people understand him on these things. Anyway, Nekobast's asking about space and time being emergent. It's a great question. We don't want to close the door on that possibility, as a lot of people would seem to want to, like just to say, well, it's got to be that it's not. Okay, I understand why people want to think or do currently now believe that space or time is not emergent, which it is emergent, is because of the Big Bang. It seems like that was t equals 0. It's been dominoes ever since. Problems in the Big Bang, right? You can see that it's essentially just a religious argument to justify God. Thanks, so tangible of coming on to instantiate an anecdote of that. Back to y'all.
So when it comes to Wolfram, he would call himself a physicist. He would say that he's trying to describe reality. It relates back to what Jen said about the monad being the thing which instantiates movement in some senses, the fixed thing which instantiates movement. So we can imagine what Wolfram is doing is he's creating a system. In some sense, there's something fixed in the background. I'm not sure what it is, but there's still motion in his system because he wants to establish reality with it. If he was just doing mathematics, I don't see what it says about reality. Because to me, what I'm cutting up a block almost arbitrarily, but I'm saying the thing that I'm going to call mathematics, that's crystal. If it moves, that's physical, right? If it's got motion. There are some people who disagree with this. I forgot the guy's name, but you might know about him. But he's that guy who says that literally all of physics is just mathematics. Do you know who I'm referring to?
Oh, I've heard this before. I'm not familiar with the concept.
So, well, how convincing is that? Like, do you think there's some credence to that?
It's like, well, that's the idea. Like, again, it was like I know a lot of people would go in the argument that, well, the mathematics is a human construct. It's like, yes, that's the symbolization. Okay, please, we know that.
We want to go past that and account for why it seems like math is intrinsic to nature.
Right, and that's what I'm saying, because computation, right, integers,
part of the answer, but order
right?
is the actual
Equivocation.
answer.
These are things that exist. Those are the things that mathematics is based off of, right? A symbolic system, right? Those are that's the heart of math, right?
No, our willingness to put that stuff in symbols is because we're transfixed by the beauty of the order of nature.
Well, that's what I mean. Why isn't the computation
just another turtle to say computation? What does it mean to compute? Did you watch my thing with a logical floggable blobbable?
Well, actually, you're right.
Why is he wrong?
Well,
explain to me how you understand why he's wrong, because you should, because it's important to a lot of people. It's the Kurzweilian view. You should understand
I will say this: the computation is probably not the right word. If I chose the best word, it would be conjugation.
It is the best word, but you have to define it accurately.
Well, computation requires like for this, if you can imagine like a set value, right, which all other values are built off of, right? And that can be true in a sense, but it's also possibly true in a sense that the equations are in a sense, kind of manifesting themselves as they're progressing, right? And that a conjugation, right? For the terminology, I don't know how deeply any of you guys have gone into the word, right? But it's an interrelational, like, it's like that you can have a set of symbols, but that you can conjugate these symbols in a variety of different ways, but the set is always there. So it's, are you guys following this? I might be getting a little too abstract. Don't want to veer off too much into the ether.
No, I'm not getting it. So
Yeah, man, I
get the
have a
analogy.
very hard time
the
following
point?
most of what you say because there's no central theme. It's like with Duvid, a series of facts. It's like, what's the connection?
Yeah, Jen, the central theme would have to be like, it's going to veer off the topic of the, of tonight's discussion, right? So that's
I think you're trying to say something. I'm trying to grasp what you're saying. I think you've got a point. So you're talking about there's a set and we can conjugate the terms, but the set still remains the same. Like,
Yes.
That's the analogy. What are you trying to tie it to?
Well, to the idea of like it's an interesting construct, right? Because it's like equivalent to like how biology like conjugates itself, how there's a feedback, right? A phenotypical feedback, like that feeds into, it changes the equation, like the root equation, and then continues the cycle itself over and over again, right? Continuously modifying, right? Feedbacking. And equivocation might be this, right? Computation, I don't think takes this into account, right? Because it's saying that this fixed formula that doesn't change. And it's like, what if the processing of the equation actually changes the root concept, right? The root value assessment, value assignment. It's possible.
I'm still struggling, but is this related to like the whole tautology thing about how like you can have a form and you can like express it in different ways, right? Like,
Yes.
like Wolfram's rewriting system. It's like we have like equations and we have ways to like manipulate them, and we can show like things are related to things, and it creates some sort of geometric pattern. I just
Yes.
In terms of that, I want to bring this all the way back. I think tautologies have value, right? If I just say A equals A, maybe there's some content with that. If I say 2 equals 2, for example, okay, 2 equals 2, fine. If I say 1 plus 1 equals 2, that's a tautology. And yet I feel like I've said more than what I said when I said 2 equals 2. Like 1 plus 1 equals 2 has more content than 2 equals 2. Even though they're both just true, and they're both just trivial, right? I think a fun part of what a mathematician does is saying trivial things in non-trivial ways. For example, you can have like identities where you have really weird equations on the left-hand side, like a really weird expression on the left-hand side of an equation,
Sorry,
and a
it's
really
not
weird expression
trivial.
on the right-hand side.
It's not trivial. It's tautological. Math is about tautologies. It's things that are always true, and that's not a bad thing.
Why would you disagree with the word trivial? What does the word
Because
trivial
you're
mean to you?
saying you said math is trivial, and no, it may be tautological, but it's not trivial because trivial means it had no information associated with it.
Okay, I agree with you then. If that's how you use the word, yeah. So the best example of this is Ramanujan's work. What he would do is he would spend his time coming up with really weird equations where there's a weird expression on the left and a weird expression on the right, and yet they're equal. And mathematicians would look at this and they'd say, how the hell did this guy come up with this? Like, it just doesn't make any sense. And why is this true? It's like a puzzle. A great one, for anyone who's curious, is the sum of the reciprocals of the square numbers equals pi squared over 6. So that's 1 plus a quarter plus a ninth plus a 16th plus ... forever. And that equals pi squared over 16. Pi squared over 6, sorry. So the reason why I love this so much is it's tautological. It's just an equation. Yes, it's true. The left-hand side does equal the right-hand side. Great. But it's got so much content and mystery and excitement behind it. Because the left-hand side is to do with sums of reciprocals of square numbers, and the right-hand side is pi squared over 6. What the hell have they got to do with each other? Why is pi coming into this when the left-hand side is just about square numbers? What have square numbers got to do with pi? I thought pi was to do with circles, and how are circles related to squares? And this is like great exploration. The content is not in the equation just being true. Like, that's boring. It's like kind of this meta thing of why the equation is true. And that's different to a proof. When I say why the equation is true, this is back to storytelling. I want a story to understand why this is true in a vague sense why, not a proof sense why. I don't know if that makes sense.
It does. That would, I think it would take just, again, for me, it's acknowledging the obvious, right? It's like, why is it true? Is it difficult to say just because it is, right? I see that like what was described there as a function of like compression, decompression, like in an equation, right? It's like you have the one side an uncompressed form, and then the other side a compressed form, right? But they both equate it to the same thing, right? And I think I don't know if that analogy makes sense to you.
No, I know exactly what you're saying, and in some respect, yeah. But there's a surprising element to it, and this is where the human comes in, because the computer's just going to look at that, and it's going to compute the left-hand side and compute the right-hand side and go, yep, they're the same thing. Everything works out here. But the computer's not excited about it. The computer doesn't look at it and go, oh, that's really exciting. That's interesting. Why would that ever happen? The human has to say why. And that's how new mathematics is born. It's to like be interested in something that a computer wouldn't be interested in. Because the computer's just going to give it a tick and say, yeah, let's move on to the next equation. Whereas the human's going to go, can I think of this in a different way?
That's true. I meant, like, I guess computers right now are kind of relegated to be just a kind of a phenotype of us, right? An extension of us. Hasn't yet become its own entity, like autonomous yet.
Yeah, let's not get sidetracked.
I didn't know
Right.
this was a conversation on transhumanism.
No, but it's
Really, it's supposed to be questions about math. To me, normally.
I like Einstein. Einstein, what have you got to say?
Oh, Einstein.
Hi,
There's a
everyone.
lot of story around that narrative, dude. You'd have to be more specific about something, because it's like, well, the character of Einstein. Do we go through that? All
No,
the
this guy right
claims
here.
and proposals that are made. I don't
I
know.
just like Einstein. I'm a huge fan of Albert Einstein. So, yeah.
Oh, nice.
So
Is that his name? I
yeah,
couldn't see him.
Yeah, that's his name.
Sorry.
Gotcha. Makes sense now. Oh, please go on, dude.
Okay.
Sorry for interrupting. It was trivial.
No problem. Yeah. So, I wanted to ask a question on like the laws of math and whether they have capacity to cause
We
something.
don't have laws
So,
of math like that, like the laws of logic.
Okay, I'm
There's no
sorry.
equivalent to that in math.
Okay, maybe what I'm trying to say is the rules of math, or
It doesn't work like that either. Mathematics
Oh.
is a large discipline wherein axioms can be invoked, and with other things which may not be axioms, to create means to essentially make measurements, usually with geometric forms.
okay. I'm sorry
That
for
cannot
not
be
being very
reduced
specific.
to. It's a great question, because it seems like they ought to be compatible, logic and math. That's why one of the questions that comes up when I ask people to contemplate is, what's the actual difference between logic and math? Can people actually articulate that in a way that makes sense?
That's an interesting point. Einstein, what's your point that you're trying to make?
Yeah, it's that it was an argument given by John Lennox. I'm not sure if you're familiar with him.
He's
but,
the Bible guy? Like the Catholic
yeah.
guy? Okay.
Yeah, I'm not sure if he's Catholic, but yeah, he's a Christian. So, what he says is that these mathematics alone has no power to create things, right? What he does is you need a mind to actuate. I mean, to cause these things to happen. So when you say
Okay.
circle, or when you talk about area of circle, in and
Mhm.
itself, it does not have any power to cause itself, right? A circle cannot create itself, or I'm not sure. I don't know what to call that, or laws, or I think there was a discussion earlier on prescription or descriptions. So I think John Lennox, he assumes prescriptions or prescriptive mathematics. I'm not sure. I think that's the case. So what he was trying to say is that math alone cannot create the universe, or what we need is a mind which will actuate these things to work and to exist in
We really
some
want to
sense.
get
So,
into the mind conversation right now.
No, no, no. What I'm
honestly, we
trying to
should keep it on math now because the
yeah,
mind
yeah,
conversation
it
is 10
is.
times more complicated.
Yeah, it is on
Same.
math. So my question is, when he says that, do you think there's anything in mathematics that allows it to happen, or do you think it's even possible?
According to me, I think the answer is no, but I'm open-minded about it. Like I said, there are positions out there where people think all of physical reality is literally mathematics, and that like we feel as if there's motion, but we are literally a mathematical entity, and somehow we have the illusion of like movement and motion, but we're kind of like this crystal abstract object. But for me, no, I think there's an extra component. I think there is like physics. I'm not going to say it's a godly mind, right? That's created like motion and movement, but there is this undeniable appearance of motion, and I don't think mathematics alone can account for it, although other people disagree.
I go through my
Okay.
example real quick that I just threw in the stage chatter. We were talking earlier about there being a pie that popped out somewhere. Remember that?
Okay. Yeah.
You were like mystified. I just want to show you how a pie popped out of my reasoning process. So starting with as few subpositions as possible, just boundary, that's shape 1 top left. So you get gravity acting on that. What's that going to do? Minimize torsion about the center of mass, right? But we have this balance. You can look up the Jolly-Dixon cohesion tension hypothesis. A basic attribute of non-solid or liquidy matter is this balance. So there's gravity pulling it together, but eventually everything kind of gets stuck, and it's like, okay, well, everything's in that state where gravity is actually now balanced by coming out
Torsion.
electrostatic field. As we existeth in the region of the cosmos, which is not a large region where the periodic table is well defined, it defines electrostatic fields as well. So the planet Earth doesn't proceed to collapse for all time under its own gravity to nothingness because it eventually finds a balance with electrons. So that's your basic intuition. So now we've got step 2. It's going to go to a sphere. Why? Minimizing the torsion about the center of mass. Why is that important? Well, center of mass being a thing and being valuable for physics, are you useful? It's your best evidence that particles exist. That's like the basis of, well, okay, let's not go there for now. But anyway, you got a sphere. You see how you can get a sphere spontaneously just by invoking a version of the least action principle. Are you following so far?
I know exactly what you're saying.
Gravity
But
can
then
act more. Gravity can act more if the surface area is distributed through a larger surface. You can see by taking on wave-like properties, it's pi times longer because the amount of surface is corresponding to the wave front length, not just the wave, not just the surface. See?
right, but it never quite gets there.
The idea
it
is
tends
it's
to
a model. It's a model for what's actually happening. It's about what is the truly minimum energy state. And if you have a larger surface per same volume, that's less internal tension, isn't it? Therefore, the state is preferred, i.e. gravity can do more work in that state.
Okay, the least action principle, and you'd apply that to the hyperbolic figure 8 knot as well.
I didn't actually derive that. What I'm trying to do is help the person who did discover it get the most out of it. So I have yet to actually have understanding from first principles of where that thing comes from, nor can I actually confirm that it predicts the constants of nature, though I would say if people were, pressed, I'd give it an over 50% chance.
Okay. Yeah. If you can ever make that happen, like a discussion with that guy, like make it happen.
I think he'll probably come on. Yeah, I mean, I'm pretty sure I haven't asked him yet, but I will ask him probably in the new year.
Yeah, you're
Daryl's
very
asking me
charming. I think you could make it happen.
Hey, I'll give my best shot. Does gravity act on surface area? Yes, you got to think of it as gravity basically being the only force happening here because really isn't much other than gravity on the scale of the object if we're talking about a cosmological object. So just thought I would put that in there now because it seemed relevant in terms of like, how do we actually define things so that they're measured correctly? And the question about, well, what is a year? Well, the correct way to define a year is something that you can measure, i.e. time around the sun. A year time, that is, out of all the things that we might find to be real, that's one of the most real things. And it's a question of like, well, how absolutely real is time? That's where it gets very complicated.
I think let's circle back around, no pun, back to what Einstein was saying, okay? Because I want to know his opinion. I don't think you're a theist, are you, Einstein?
Yeah, I'm not a theist.
Okay, so what do you think actualizes motion?
So what I feel is that there's an undiscovered law that just made it happen. So it's just not within our understanding yet. So and I think it did pose an interesting question on how these things can actuate all by themselves. Okay, they don't have any intrinsic, at least by the understanding that we have. When you talk about equations or all these things, these in and itself assume that something is already existing, and we're trying to describe what we observe or things like that. It's nice that we try to create something with these equations. So I think it felt like a challenge to me, when he said that you need a mind for something to create, and mathematics alone is not enough. So I'm using the word
Well,
mathematics, but it can be pretty much anything. So something that's abstract. So what he generally meant was that abstract ideas don't have power in themselves to create. So what we need is a mind to actuate things. And I think that is a challenge, and I'm not sure how we can solve it, but I do feel like there could be something that we haven't discovered yet that can help us figure it out. So
maybe.
I was just asking. Yeah.
You listened to the conversation with Vitangelo, right? Right, like, I don't know if
Yeah,
you were
I
there.
jumped in and out.
Okay, well, what he was saying is he thinks, like, Jen was, like, battling him when it came to, like, a first cause, and that, like, Jen's happy with, like, the universe being, like, the thing, and not worrying about, like, issues with that. And Otangelo's not worried about issues as well. When I brought up the fact that, God is, like, this unchanging entity, like, he created stuff. There was a point where there was no stuff, and then there was stuff. And when I say a point, I'm not talking about, like, time, because that's just presume that, like, physical time started when God, decided. It's like a causal thing. But he thought that, God was this unchanging entity, and that the universe didn't have to exist. But if God, like, I don't see how, like, throwing a mind in it does anything, because you have this unchanging entity that somehow made something happen. Like, it made a decision without there being a notion of time, without there being a notion of, like, movement. He chose to do it because he didn't have to do it, according to Otangelo. So there's a paradox there as well. I feel like this is a really complicated problem, and just, like, throwing in a mind as an extra ingredient doesn't really solve it.
Okay. Yeah, but you do think that it's a complicated problem, right? Like the fact
Yeah,
that these
definitely.
things. Yeah, I think that's when I kind of liked, he made me question. Usually, whenever a theist speaks, it doesn't make sense to me, or it doesn't feel challenging. But I think that idea it did challenge
Well,
my beliefs.
well, okay. This is kind of like somebody is posing a really interesting philosophical problem, and then they're just, like, quickly saying at the end, "But we have an answer. It's God with a mind, and it's the solution to this really hard problem." But, like, no, if you just, like, think about, like, does that actually solve the problem? I don't think it actually does. So, I'd rather see it as just, like, an interesting problem. It's the same with morality, right? Like, they will, like, be, oh, why do we have, like, this moral intuition? Where does it come from? God's the answer.
Think about it for as an accounting of universal ordering principle.
That's a nuanced perspective on what morality is. How does that work?
Not morality, no, God.
Oh, okay. A universal ordering
The
principle.
God mind thing.
A
The
universal
universe is
ordering
ordered
principle.
because it's in God's mind. Accounting for why there's a perfection in the universe.
So,
Yeah,
does
but
anyone here think that math is prescriptive?
We talked about this before. I'll be honest. I don't even understand what that's even. I can't get enough clarification to answer the question. I'm sorry.
yeah, funnily enough, I brought up the words themselves, and it's embarrassing. I don't even know what I mean by them when I say it, but I know that what I'm saying has some content. Let me try and flesh it out a bit more. So I don't know what it means to like for a law to be prescriptive. The reason why I'm bringing up this dichotomy is because people think as if laws are prescriptive. They'll talk about like, oh, the laws of thermodynamics, blah blah blah, as if they couldn't be wrong, as if like they're a necessary truth of reality, rather than just like someone's come up with a model and goes, yeah, it kind of works, it looks good, and maybe we have some like other reasons as to why we should expect this to be the case. But there's this thing called I don't really know much to speak on it actually, so I probably shouldn't. But there's like a new theory of physics about counterfactuals. It's where reality does whatever it does, but it can't do the impossible. And so equations are like restrictions. They're like saying reality must obey these equations and can't do things which go against these equations. So in that sense, they're prescriptive. They're prescriptive in the sense that they restrict what reality can do. So
They're not prescriptive, they're restrictive.
they're restrictive or descriptive. Maybe we should phrase it like that.
Should
But
just use the right word, honestly, because prescriptive might just be too vague to actually be informationally viable for the conversational purposes.
that's a good point. Yeah, restrictive. So, you know, like we have equations and they restrict what can happen. What's kind of interesting is, are they restrictive enough that there's a unique solution to what reality can do? Right? Like, is there enough constraints on reality that only one thing can happen, like a deterministic universe? Or is there like wiggle room? Like, you know, there's kind of a lot of different situations that can obey the equations. It feels like that is the case. I mean, I could walk to the left, I could walk to the right. It feels like reality can't stop me doing that. Like, there's more than one thing that can happen. So, but that's a kind of a weird way to think about things, and people are trying to make that work in a like a real sense. I don't think of mathematics as doing that. I don't think of physical equations as doing that. I think of them as attempted models of trying to figure out what reality is doing, rather than restrictions on what reality is doing.
Nice one. What do you think about that, Einstein?
Yeah, I do think, like, even I think that it's, to me, it's like everything is based on what we observe. I don't see like we have any access to anything that's absolute, except I think it's just my own consciousness, I guess. But yeah, I just wanted to know if there's anyone out there who's like, who thinks that math is prescriptive and how they might justify it. But yeah.
What do we mean by prescriptive? Can you give us a definition of prescriptive? As in, I'm God, I prescribe that the universe ought to be this way. Dun, 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 dun. Because I'm sorry, that's what I'm thinking. Like, that's why I'm like, that can't possibly mean that.
Yeah, I mean, it's something similar to what Euler was saying. I mean, I like when you say prescriptive, it's that the law is, it's like never changing. It's absolute, and I mean, it actually describes reality on an ontological sense. You know, there's it's not like tomorrow you discover or observe something new and it changes. So
Do you agree that
that's what I
how
think.
reality exists and where the starting point of knowledge discovery ought to be, those are completely different questions and not necessarily connected in any way, shape, or form?
Not sure about that. Sorry.
I'm not saying they're unconnected. I'm saying that there's not necessarily any connection between them.
Okay. But I do
Feels
think
like
that
there is. That's a problem because we have a perceptual limitation. We can basically prove that our
yeah.
perceptual faculties are deceiving us.
Okay, I'm willing to go for another 20 minutes, and I'm going to call it bedtime. If we can invite Albert up to see what he has to say. And if anyone else wants to say anything, we've got 20 more minutes to talk about things.
I invited them up. Welcome.
Hello.
Hello. Oh well. It was quite a bit ago that I raised my hand, so it might my input might be outdated by now.
I'm really sorry about that. And going forward, tag me in the main stage chat, and I'll try to remind people for that. Like, I don't always use raising their hand, and no one necessarily tells me. I
No
guess I
worries.
strike fear into the hearts of men. So my apologies. I'll go back
Yes,
to
yes,
muting
I'm
now.
terrified.
Yeah,
no,
thanks for joining us, and sorry about the wait.
no, it was interesting enough listening in.
If you ever reflect on yourself, you know why you scare all the men. I'm not a man, I'm a monster, so I'm not scared.
Do you remember what you raised your hand for?
It was about mind creating mathematics, and I very much dislike these kinds of notions that mathematics is somehow objective, or that it is created by some higher deity, or that it is this platonic version of itself. And no, mathematics is just a language that we are constructing for its use purpose, which is to describe things. It is if whatever math is, it is what we call math.
Okay, so the way I feel about that is it's not just descriptive, because kind of what Jem was talking about is, okay, like we can describe planets as being sort of roundish, but we kind of go one step further. We kind of want to refer to like an ideal sphere, like the perfect sphere. And it's not, it doesn't feel, sometimes it feels like it's not just a fiction. Like there really is this perfect sphere out there that we're sort of connecting with in a platonic sense.
Like
Why-
that's like the old conversation of what is a chair in philosophy. Yeah, if we have no perfect definition of chair in the English language, because the English language is just too vivid and prone to change as it's a commonly spoken language. But mathematics is specifically designed as a language to not change. So we can say, okay, we just define a thing, and however we define it, that's now the definition, and that stays the way it is. It's not that we can't change these definitions, but there's utility in keeping them pure and rigid like that. Like what is and isn't a prime number has changed over the years, because mathematicians were annoyed by the fact that they constantly had to say, excluding one, prime numbers have these properties. Like, yeah, okay, we can do that all the time, or we can say, no, for the use that we have mathematics for describing things, it's more useful to just say one is not a prime number, let's go on with it.
Okay, but maybe like the thing that we're like thinking about hasn't changed. It's just like what we're associating the word prime has changed. And also I really like that example. You know, like one was a prime number and now it's no longer. There are some people, John Conway included, he actually wants -1 to be a prime number, and I can sympathize with that.
I dislike that.
Well, yeah, see, we have like aesthetic preferences on what we want to call a prime number, but it's let's like separate the word prime. Like we have this like familiarity with the word prime, and we love
just
it.
work backwards from the utility.
Yeah. How can a negative number be prime?
There's reasons for doing it, but let's not get into it.
To get into that it would be a bit too deep. But yeah, like the reason that we say this is how we use mathematics is because of the utility, not because there's some intrinsic truth to any of that shit. There's still the old debate about pi versus tau, and nobody's actually using tau though, unless you like this in university as a meme between the mathematicians and physicists. But it has just shown that it's much more useful to use pi, so we are using pi all the time.
Well, I don't know if that's it. I mean, there's historical precedent for pi, and it might not be like utility. We're just kind of stuck with it for historical reasons.
But
But
that is utility.
let's not confuse the map with the place, right? Like, we've got these words that we care about. Like, we care about the word prime, and it has like a fluffy feeling associated to it. And so we want to be careful about what we're connecting the word prime to, but we're still making a connection to something with the word prime.
We made up a definition. And when we are saying that is what we define prime to be, that is what we associate with it.
But the definition is connecting with something out there.
It is connecting with the consequences of the axioms that we put up. If we would change the axioms, we would change what if something like a prime number even exists.
I agree.
The prime numbers are a phenomenon that we are seeing that results logically out of the axioms that we have in the common mathematics that we are using today.
I agree. So the way to get around this issue of like it, you can think of like mathematics as being like a tree, right? And like we create the axioms, the roots, and then the tree sort of grows, and there's theorems and there's fruits and there's all sorts of exciting stuff going on. And you are saying like we could come along and we could change the roots here and we'll have a completely different tree. And therefore, like, how is mathematics really out there if it can just change if we decide to change the axioms? The escape of that is to say, no. There was never just one tree. There was always a forest. There was always a collection of axiom systems out there. And it's not that we're chopping down a tree and planting a new one. It's that the trees all exist. We're stuck on one tree because we've got, like, for historical reasons and historical precedents, we're fixed with this axiom system. But there's no, like, we can just, like, turn around and pick a different tree. But they still all exist.
We do that in mathematics. There is not just one set of axioms that we use all the time. When you learn mathematics in high school, you probably all learn the same kinds of axioms. But in different areas of math, and like especially when you go like non-Euclidean and shit, like you might get at points where it's more useful to use to use axiom systems that are different from the standard one we are using today. And it's just based on the utility of it. Like we don't care about mathematics being consistent and complete and such because these are like great things intrinsically. We care about it having the utility. And of course, there's the historical precedent that has ingrained a lot of ways in how we are treating mathematics. Maybe the whole debate between pi and tau is just based on historical precedents. But because there is this historical precedence, it is just easier to keep on going with what already is there. So like, okay, changing every math textbook to tau now might not be that would be a huge effort to just a small, if any, impact on our actual utility.
I misunderstood. Like, what is tau?
Tau is equal to 2 pi. So the idea is like there's a bunch of equations.
You used to dry yourself off when you're all wet.
A towel, yeah, that as well. So there's a bunch of equations, right, that have pi in it, right? Like for example, a circle, right?
Yeah,
like
so no stupid questions, folks. There you go.
I'm talking about serious stuff here, guys. Calm down.
No, that's my job. It's the stupid questions.
Look. The fact that we would care about tau or we would care about pi has like literally nothing to do with mathematics. This is like the sociology of like mathematicians. It doesn't speak to the content of mathematics at all, right?
You could argue on a utilitarian basis. You could say pi d is better than what? Tau pi over 2?
Okay, yeah, exactly. So circumference is equal to pi d, right?
This pure sex.
You could say that we also know circumference equals 2 pi r. Okay, so if you prefer radii, 2 pi r, you could say, no, circumference equals tau r. Circumference equals tau r. So certain equations look better when you introduce the symbol tau, and other equations look better when you have the symbol pi. For example, in complex analysis, there are integrals everywhere where 2 pi appears. And it's kind of annoying because all the time you have to write 2 pi. I'd rather not write 2 pi. I'd rather just write a single symbol rather than wasting my time writing the 2 in front. So I can instead just write tau instead of writing 2 pi every time.
Yeah.
Although
Yeah,
you don't
but
do that.
I think it has to do with basically popular habit.
Yeah.
Yeah.
That's
Yeah,
all.
Because we're using R in the definition rather than D. So are you saying you'd
Yeah.
like to switch to D? Because maybe D is actually more symmetric at the end of the day. D being
Well,
diameter, for those of you unfamiliar, R being radius.
yeah. That is something that I was like referring to, like these that how we are using math and like what I like the symbolism of the mathematics trees that we have. Like what we choose as mathematics trees is just based upon what is based on the utility we have out of it. No, the utility is not just based on the actual practical utility of using it, but also like the historical precedence. I acknowledge that, but it's still like the reason that we choose any of those is just because of utility. There's no intrinsic property to anything that we are talking about in mathematics that is actually true somewhere or that is created outside of the human minds.
But you're not saying
Question.
anything about what mathematics is. You're talking about the sociology of a mathematician and how they have to navigate this forest.
Because mathematics is all just sociology. It's just a one language like any other language. You could also say there's the tree of the English language. And there are
Albert,
a million infinite possibilities of how you could speak English, but there's just
But
a certain variability that we can have while we still understand each other.
that's an interesting point. God, what's your
back
question?
on some Jen said. Jen said pi d, pi diameter, versus 2 pi r or tau pi or tau r. Wouldn't
Yep.
they come out similar? Wouldn't they come out to the same quantity?
Yeah, exactly.
We're talking about which identity makes more sense. I don't think anyone said this, but it's basically a metaphysical brevity argument. It's like, why would we opt for tau or pi? Euler's
Yeah.
saying, well, we're always getting 2 pi because to take a radius from 0 to 360 degrees, that's 2 pi.
Yeah,
You're actually using it as a measure.
that's what I was saying.
360
Yeah,
degrees. It's literally 2 pi radians is the word for it.
yeah, because you could say pi diameter, which is across, versus
Yeah,
2
so all the
pi.
equations are the same. Like the mathematics is not changing. It's the human sort of template.
It's just
Like
your
how do we want to
perception.
think about these things? Yeah,
It's how
yeah.
you say it. That's all. It's really.
Like the thing is
It's like
that
saying 4 times 2 plus 8, or
Yeah.
you can say
like
you
2
can do
times
the
4
math the other way around.
plus 8. Yeah.
yeah. Like I can come up with a new kind of mathematics or new language today. I can set up new axioms, and these are gonna extrapolate into properties that I can then like go into like finding when I use the mathematics that I've created based on these axioms. But I'm not actually finding anything out there in nature. I'm just finding the consequences of the logical system that I'm constructing.
But there is some math you can't reverse and get the same result.
Are you not talking about matrices or?
Yeah.
Yeah,
Or
yeah,
even
that is
when you're doing when you're doing Ohm's law calculations, you got to do them the right way around to get the result you want, or want to know, I should say, not the result you want, to get the correct result. Like, volts times impedance. You know what I mean? You want to know what the power is. You see what I mean? In order to get the power, you got to do it in the right order because there's 2 steps to that math question. First of all, you multiply your voltage by your impedance, right? So we'll say 4 times 12, 4 times 12.6, and that gives you 52. You know what I mean? It's a bunch of math you got to do to get it the right way around, and I just did it wrong because I'm too tired.
I was very confused.
I'm that tired. I've been awake for about 36 hours.
No, I get what you're saying. There are some things in math which are just a bit like superficial, like changing the symbol 2π to tau. It doesn't actually change the content. Whereas there's other things where doing things in a different order or changing things actually does have consequences. But I think what's kind of interesting is what Albert was saying. He was saying, you know, I could create a new axiom system and there's going to be logical consequences of this axiom system. I feel as if, I don't know if this is true, but it's just an intuition. If you're going to say that there are consequences of this axiom system, have you committed yourself to some form of Platonism where you have to say, because there are consequences of these axioms, you're like saying that in advance, as if there is content out there that can be obtained that you're going to find. If you're going to find it, it has to be somewhere, right?
No, it is not content that I find. By creating the axioms, everything else just comes tautological, as we also discussed earlier. Like
right, there are things out there. There are tautologies.
After I create the axioms of the common mathematics that we use today, then 1 + 1 = 2 is just a tautology in the system.
Right,
all these things that we are discovering there, so to say, are just things that are interesting for us to label.
Yeah, but you're not making an empirical claim, right?
Yeah, there's nothing empirical about this.
This is some sort of like abstract claim. Like you're saying, you're positing the existence of consequences of axioms, and that they're going to be there. That there are consequences of axioms.
Well, they're implied in me making the axioms.
Right. So
I got you the correct math question I was going to give you earlier, just so you'll know it. It's
Is
voltage
it a math
squared
test?
divided by it's voltage squared divided by impedance gives you the power. And it has to be in that exact order, or you won't get it.
The same conversation that's been had for like probably, I don't know, 50 hours now at least. Space-time emergence is happening yet again. Yet again in the chat.
Yeah. Oh, I don't know about this one. Okay, I'm going to end this in 2 minutes for myself here. You guys can carry on if you want. But Albert, was my point made clear? Do you know what I'm trying to say, at least?
I think I understand it, but I disagree. That
what am I trying to say?
There is this Platonic ideal of this mathematics before I created the axioms, and I just decided which axioms to use, and then I just discovered the things of that are implied in this axiom, that are like consequences to the action of making the putting up the axioms.
Which mean, like, in what sense are you not committed to their existence?
Well, of course, their existence is completely abstract in this sense, but besides that, in the terms, the English words that I'm using, axioms, putting them up as axioms, I am already telling you that because these words imply certain things, that I am implying that I'm putting up rules that are in a logical system, and because I put up rules in a logical system, thereby follows that there are consequences to that, because it already is a logical system, even if there is no consequence in it of itself. That is the consequence of having this logical system. Or even if it's...
Did you arrive at this opinion by like induction? Like, I've observed a bunch of mathematicians coming up with axiom systems, and those axiom systems have consequences.
By the definitions of axioms I'm putting up in a logical system, I am doing a logic system.
So I feel like you commit to their existence then. I'm confused.
Well, I'm not. I'm committing to their existence as much as I'm committing to anything that I'm describing in the English language.
Yeah, but what you're describing isn't physical.
Well, yeah, it doesn't exist in of itself. It exists as a social construct.
A social construct? No, but it doesn't, because like you haven't even picked the tree. You haven't, like, we don't even know what axiom system you're going to come up with. But you'll still say that a priori. I mean, that these consequences are still going to exist no matter which axiom system you construct.
Yeah, because it is implied in a sentence saying that I am creating a logic system. I am implying that there is going to be a system. If I don't say that I'm going to pick axioms, then there are just no axioms being picked, and thereby no logic system to be formed.
Okay. No, I don't get it. But that's a good time for me to like bail out.
Yeah, okay.
I really appreciate the discussions.
Hey,
Thank you so much for
Send me a-
suggesting this. It was a wonderful. I'm still down to hang out, so we don't have to wrap up if there's still people that want to chat. And if it's not with me, if you want to talk to each other, that's cool. I can hang out for a while. And,
Yeah.
don't have
Yeah.
anything
guys,
else going on.
gotta
So
tell him,
thank-
dude. Go send me a friend or send a friend's request or whatever. Accept it.
With French request.
Me? Are you asking me
You.
for a friend? Oh yeah, you've sent
Yeah.
me one. Yeah, I'll accept it. There we go. Okay. I appreciate the company, guys. Thanks a lot. Good night,
Yep.
guys.
Party on, dude.
I have a question for Albert.
Oh, go.
Yeah, when
Go
you
ahead.
said that you'll create your own set of axioms and then work from there, and I understand your point that you'll naturally arrive at certain, consequences because of those axioms. But when you say when you say creating these axioms, do you think you can create something that's very different from the set of axioms that we already have, or do you think they'll be very similar in nature?
Hey, they could be whatever I want them to be. Like, they can be similar, they can be different, it can be anything. Like,
Okay,
all I'm
so
saying is I'm putting up axioms whereby I put logical rules that I'm going to abide by when operating the system.
okay, but the nature of how they work and how you infer other things, it will all be the same, right? Just like all the other math that we're doing. Only the notations are changing.
No. The notations is like notations is basically just the notations doesn't have anything to do with the axioms themselves. Notation is just how are we communicating the thing with each other. It's not how we make up the thing that we are talking about. Like we make up in society we have somehow made up English grammar, but we can invent new words and use different words to describe the same thing all the time. As long as we still use the same English grammar, for the most part, we can still understand each other.
Like, did you ever try this out?
Making up my own axiom system?
Yep, something. I mean, I'm sure it's a very difficult task, but something that's
It's not really
doable.
difficult. Like,
okay.
if you go into like some basic university course on logic of math and then learn the axioms of mathematics, then you just can play drag and drop and make your own axiom systems. No, most likely they are gonna be ones that or people before you have thought of before, but maybe you're lucky and you find a combination of axioms that nobody has thought of before.
real quick to answer Quantum's question there. It's fatter in the middle for some reason. Okay, here was my logic. Now, again, you got to understand that what I've got for my diagram, artistic interpretation, artistic interpretation, artistic interpretation. So it's about the information that goes beyond the artistic interpretation, right? Why did I make it bigger? Well, why would hydrogen and helium be somehow different from the rest of the elements? Well, they're fundamental non-dual, the s orbital. So you can say like every other orbital is, I want to say a copy of the s orbital, but that is one interpretation. Like it's not my own whack job interpretation. It's anyway. The point is that there's a span of density of the proton, or sorry, the nucleus and the electron. And there's quite a variance in that density between hydrogen and helium. So I wanted to capture the large difference in basically properties of hydrogen and helium gas. Good question. I mean, technically, it is just one entity. It's been broken down stepwise energetically in a still meaningful way, but this is not what reality looks like. Like, to get to reality, you need to then condense this into actual geodesic. Like, I don't know if people can tell just by looking at this, but it's not a geodesic. Certainly not a gravitational geodesic. I don't know if that's obvious, but it does not have a symmetry we could argue is of a gravitational variety. It doesn't look like a planet, in other words. Anyway. Einstein, you were muted before, but did you want to keep talking? Because I think it was your turn. Not sure if Einstein is still there.
For some reason, all I know it's only just a bunch of balls. That JPEG there looks quite cool.
Well, it's meant to be partially therapeutic, so glad you like it.
Oh, it was you that posted it. I didn't even look see who posted it.
Oh, this is really hard to follow. I'm impressed with Daryl.
What did Jag just give me? Whatever a rep is. Gave +1 rep to me.
Okay, so Einstein, are you gonna unmute and say anything? Because if not, I'll probably just head out now. Unless anyone else wants to raise their hand in the audience, because looks like we're going for about 3 hours and it's sort of died down.
It happens. That happens.
Yeah. I think I have a general question that's for myself. It is I think it won't take long. It's just that I find it very difficult to distinguish between things, when it comes to physics or math. How to make a clear distinction between them? Is it just how we define it, or because there's a lot of overlap? I see people say that physics is all mathematics, and some say I just don't know where to draw the distinction and how to.
The distinction is that physics is a science, mathematics is just trying to advance, create new ways on how to do math itself. There can be cases where mathematicians, through their rigorous work into mathematics, can pave the way for new physical discoveries, or that physicists will come up with new ways of doing math because they need new ways to explain the things that they're observing. But generally, it's the physicist tries to explain something with the math, and the mathematician is trying to construct new ways of doing math and understanding the math that we have. It's the difference between a sociologist and a English major.
Okay, so it's just that we're trying to apply math with what we observe. That becomes physics, and when we just simply assume these axioms and build other things, it becomes pure mathematics. That's it.
Yeah. Well, we use math in all sciences, but like in physics, it's very egregious because of how much we need to describe using mathematics. It's just useful that way. We could do it in English, but that would just then the papers would like be 10 times as long.
Yeah. You're right, does make it more compact when you can do stuff mathematically.
Again, you have no basis to make that claim. It just seems that way. But a lot of stuff has been sort of revealed about how mathematics seems, and to turn around and validate that in a meaningful way, that's extremely challenging to do. I'm glad we're having the combo, actually.
Well, I could ask you to explain phase angles without using mathematics.
Well, yeah. There's so many things that we'd need to like go into ultimately make sense of all this stuff. Like how
Yeah.
much signals processing knowledge do you want to have?
See, I'm into, as you know, doing
Don't-
electronics and electrical circuits.
Right.
And when you're dealing with things like
Questions.
motors, phase
Questions. I
angles
want
can become
questions.
critical.
I want questions, or I'm just going to get real tired real quick.
Yeah.
So that's the difference. Time we do not experience that does not exist, that we call the past and the future. We know about the past because past events are imprinted on space. So that's like basically not saying anything. Now, one wonders why. Well, what is the point of speculating all these theories? We want to go a little further than speculation and say, here's the evidence. And I would even suggest to lead with evidence if you can. I don't know if people know what that means, but there's a lot of talk about utility. What is the utility?
Yeah.
Various approaches.
Yeah. Jen, where I was going to go with this is that everything I do all connects back through itself with math. Math connects everything
That's an assertion and not a question, which would seem if you had a master of mathematics, which I clearly am, you'd want to ask them as many questions as possible, unless somehow you knew more than that master, which would be inconceivable, right?
Yeah. It's okay to have a conversation too, without.
I'm not really
lots and lots
interested
of
in that,
extra
though, at all.
But it's
Wait, do you have a
enjoyable.
Am I
master's in
allowed to
math
not
and
be
you're not
interested
interested in it?
I'm interested in a conversation about math, yes.
I have like another question for me. So, like when I'm learning something new, or
Yeah, and I didn't
when
even
I'm
get a
discovering-
chance to answer your question about physics and math, right? I didn't even get a chance to answer it, Einstein. Like I can actually answer
Yep.
that question, right? So there's a difference between what ought to be the difference between math and physics and what is the difference between math and physics, right? So the way it's understood right now, physics has, capacity to speculate theories which can predict future state of a system given the present state of a system.
Yeah.
There's a lot of mathematics involved in that, and sometimes the mathematics gets exchanged for reality and people's understanding, and it leads to horrible things, including this conversation. But anyway, that's a problem,
That's a
right?
great
So we want to
definition.
address it. Not really, in theory, math is more about just purely the symbols and purely the geometry without necessarily an application. It's theorems for their own sake, whereas physics is, I would say, strategic application of theorems in the interest of predictive models of reality. Whether
Yeah.
that's been achieved,
Well, every once in a while, the physicists come back to the mathematicians and go, okay, the pointless things that you have been squabbling about, maybe we do need them for our models after all.
it's always the way, is it? And now it's a question of theology. Why is math more true than physics?
It's not more true. It's never true. Mathematics is not true.
Okay, well, but you just said we have to do all this math for its own sake, so we could go back. We finally realized we need it in physics.
Hey, we need it for simpler models. It's not about that it's inherently true. There's nothing true about the mathematics. It's just useful to tool.
There's two different definitions of true. There's true as in doesn't contradict an axiom of a reasoning system, and true as in corresponds to reality. So reality is non-dual, and true as in not contradicting the axiom of reasoning system is necessarily dual. So they're incompatible in the sense that one's fundamentally dual, one's fundamentally non-dual. I have to specify which one we mean when we're talking about this. I think that's where a lot of the confusion comes from.
So like when we are trying to understand math and learn math, should there be any specific approach to it, or is it any different from learning anything? Let's say English is also a language, but
Why
I
don't
do
you tell
find
me what you think? I have a feeling
So
we
it's
agree
like
already.
I feel like it's the same thing, but when I begin with mathematics, I just it gets difficult over time. But I'm not sure where I'm doing it wrong. Is it just a psychological thing that I'm feeling, or is there any actual difference in math that is creating that difference? I do tend to see this pattern among students too. Many students who just say that, math is generally difficult. Is there any nature to how math is working that's causing that?
Mm,
I'm
I mean, if
biased.
it's
I'm going to
this,
come in with my theological explanation. So why
oh
don't you
no.
answer, Albert?
Math in itself is not that hard, actually. It's just that how we teach it is very off-putting to many students. I think everyone could go into mathematics if they would be given the right approach to learning it.
Okay, Hitler.
it's like now I'm
Math
I
Hitler.
just love to have just love to have you as a teacher. It's like you could totally understand the kids just sitting there like, no, I want to play with this.
How old are you, Albert? About 25?
Pardon?
I said, what are you, about 25?
No.
I mean,
And that would be
Because
like
you seem to have an awful lot of...
62.
Huh? You're 62.
No, you said 20 pi.
Yeah,
I'm. Why?
I'm just curious. You seem to have a lot of information.
I don't have much information at all.
he sounds very
Question
much
is,
like the smart guy from an anime.
why does it seem like math is intrinsic to nature? Why does it seem like math is intrinsic? Why does Albert think everyone can learn math? Because he has this misplaced idealism and faith in humanity.
Hey, I just
Well-
got heavily insulted as the
I'm
anime
sorry.
protagonist.
I totally thought it was completely incontrovertibly a joke when I did not mean any offense by it. But like seriously,
No,
I've
no,
been a
I
math tutor
didn't
for
mean your
really long.
comment.
I was a math tutor for like 10 years, and my heart literally broke when one of my students couldn't understand like super basic logical inference. Just not relatable to a lot of people, and it's so sad. But maybe
Because it is,
sometime they could
it
learn.
is very counterintuitive to how many people initially get taught match. Okay, maybe I'm incorrect about it, but I think we should really stop like forcing down at like little children the mathematics in a way of like, yes, 1 + 1 is 2, 1 + 2 is 3, and this is the number series, and like this cold and dry. And when you just gotta memorize everything, you gotta memorize.
That's
And
not
like
how I
what
learned.
that's how I initially learned it, and I think that is terrible, and it is awful, and it just breeds
So
a resentment against
I'm
mathematics.
yeah, I'm like the very much product of that. So I just want to get out of it and actually understand math, and I don't know where to start. So I'm just
What do
trying
you
to figure
mean by
things out.
math? What is it about math that you're lusting over? Go deeper. We're saying
can't
math
like-
here. We're stuck on this
Yeah.
stupid word. What is it about math? The symmetry, the beauty, the what? Parallelograms?
When I was in school, they
So-
taught you to carry the 3 and all that shit on top. That, I started figuring things out differently. I'd start doing multiples of things in my head and get the math.
Yeah, like I also never actually spent the time in math classes with the math that the teacher's telling us. I was always trying to like come up with new ways to solve the equations that they try to teach me on how to solve it with rigid method. And like, oh no, maybe if I do this way, I can get to the solution in a different way or a better way. Mostly because I was lazy
work?
and didn't want to go through the entire process every time.
But did it work?
Yes. And my
That's
math
what
teachers were
fucking
very annoyed when I wrote down the easy way to solve equations on a joke board after class. And I'm like, okay, I'm just gonna use that now.
There's why I was wanting to ask what your age was. I'm gonna get you to do a piece of reverse math.
My age?
Yeah.
I'm 22.
22
Yeah.
times 2 plus 4 equals my age.
No. Times 2 plus 4?
Yes.
You old. 48.
There you go. Took you longer to solve it than it did for me to come up with a question.
I don't actually engage. I don't engage with real numbers anymore. It's just symbols all the way.
Yeah, but I literally did come up with that question faster than you answered it.
Well,
Yeah. So apparently you like math.
I as a tool, yeah.
Yeah.
I'm not a mathematician like Jen here.
You don't have to be I'm not a mathematician.
You're
I'm just so used to
you're an
that
engineer, right?
I do electronics, yes.
Ah,
And
yeah.
I'm so used to, okay, I've got to have 50 volts or somewhere close to it. It's like, how do I get that? A couple B cells will get me that. They'll get me 44 volts, which will close enough. You know what I mean?
Yeah.
And,
It is very annoying to me how engineers and people that do like deal in electronics, not like software, but general electronics, where you actually do hardware shit, are all so much better in calculating in their head than I am. It's frustrating. I should do it more, but when there's just a calculator, it's easy to just grab.
but the second you said you were 22, it's like, that's the voltage of a B cell.
I know.
I
What's your
automatically
phosphor?
connected it to something instantly. Yes, that's the voltage of a B cell, which is a type of old type of battery used in the old tube radios.
Yeah.
And it just instantly is like, that's easy to remember. And it's like, okay, I'm gonna give him my age with a math question. It's just how my mind works. And that's how I do my math.
I should have given you my age as like a pi times 7 or something.
Well, pi times
or
7 is definitely...
it's close.
Yeah, it is, actually. Fuck, it actually is close. Yes, it is. It's not bang on, but it's close. I'll give you that, you.
So does everybody see how it's just that we haven't defined measurement accurately enough? We're being fucked with what's associated with that shit definition or lack thereof. Nobody? Cooler?
Quite.
Cooler?
I didn't fully comprehend what you were saying.
These problems in understanding between math and physics and other things is essentially reducible to the measurement problem, that we can't define measurement well enough, have it be a term that can go from discipline to discipline and still retain, I don't know, seems to lose essential meaning. In the sense that like there's a serious like gap in how predictive a lot of things that ought to be scientific are.
No, like the predictiveness between like disciplines, like when going from physics to chemistry is I feel like it's mostly retained. Like the predictive the ability, our ability to be predictive is more dependent upon our ability to measure accurately, not on the measurement system itself.
How could you possibly know that? Obviously, ability to make a measurement depends on the measurement system. What else is it going to depend on?
Yeah, our ability to measure.
That's the whole problem is how do we separate those two identities, right?
Yeah,
Shouldn't expect to necessarily do that on this call, even though someone on this call has already done that. It's not necessarily self-evident. I mean, no one has done it. Someone who might be me, but I'm just saying,
So
like,
you're
people have been
Um,
listening for this. This is basically, I'm sure, God, you've taken some psychedelics.
oh
You've
yeah,
seen some
and by the
shit.
way, your tolerance for your math there on 7 times pi is 0.00885 and so on with some change after that.
People have been
Off.
trying to bring stuff from the other side
That's
for
how
a really
close.
long
I
time.
I do use pi a lot.
It's
Doesn't
point
usually
zero
work,
zero
is my
eight eight
point.
five something or other, a bunch of pocket change.
Yeah.
That's the
There
difference between it
there
and 22.
there are two numbers ingrained in my head. With P and I and E, P and E, and then it's just all the I cannot get them out anymore.
Yeah.
As I
No, for
said,
me,
numerology is the first step towards insanity. So I want to
Yeah.
avoid insanity, I think.
I can literally, just by dictation, without even reading it, walk you through cover to cover the RCA Radiotron Handbook, cover to cover. You just give me a tube number that could be in that book, and I can tell you exactly what it is, how it works, what it's for, and the applications and the pinout. Just bang.
Bang, bang, bang.
Yes.
Yeah.
So we both got our little sweet spots in our brains for something.
Yeah.
Yeah. I'll just keep you around. You're really a lot better at math than I am. I'll give you the easy questions.
I'm no good at math.
So you're
I
saying
do
it really should
physics.
get, so you're really saying it should not be sarcastic when I say give you the easy questions. Right?
Yeah. Oh no, the real did the engineer joke. E equals 3 equals pi. Oh no.
Is this fabled fun I keep hearing so much about?